Mark 5. ET2. Okay, now, Tom, remind me which one goes on the right.
Okay, the one that goes on the right is 1006.
Okay. Let's watch it. Story. We got it wrapped around here. Okay. All sorts of tether loops. That's it. There it is. That's very hard. I don't know why. Okay. Are you ready to? You can give me a ride over to the telescope? Okay, folks, we need to come on in.
Okay, Jeff, coming in.
And I guess I need to take your power tool. I can hand it to you when you're ready.
Did
I just want it now.
the new battery help your tool, Jeff?
I didn't try it, Tom. It won't make any difference until I put a load on it.
Okay, copy.
In fact, we got to keep coming in. I'm about 3 feet too far out.
Okay, bring you in about 3.
Hey, Tom.
Sir.
Being very warm.
Great.
Okay. And I'm just fine. My temperature.
Still setting on 2, right, Story?
I think I'm max hot now, but I can't. I'll let you know.
That's not a big deal.
I've not touched anything cold since the toolbox.
Okay.
Okay. Come forward about 1 foot and in 1 foot.
Forward 1 and in 1.
Okay. Subtract 5. C2. Loosen.
Stopping.
Sachs, you got to bring me up a little bit so I can lean forward.
Going up?
Or actually, I guess what you really want to do is bring me up and then roll me forward.
Okay, do you want orbital roll or body roll?
End effector roll.
Yeah, okay.
Again, the task we're watching is the change out of the electronic control units. Both astronauts up around the left side of the telescope.
In a little further, into the telescope, into the top there. Now hold it up. Are you ready? I'm ready. We're going to have to redo this when I have to pull down on it, Story, but let's get it off at least. Are you ready? Our body positions, so let's take it off at least. Are you ready? I'm ready. Here we go. 1. It's coming up. 2. 3. 4. Coming up nicely. 5. 6. 7. 8. try that now. I'll take the tool. I got the tool, good. Okay. Comes out like a charm.
That should be serial number 1002, right?
That's correct.
Good.
Operating the robot arm for this task is pilot Ken Bowersox, who is trained along with Claude Nicollier in operation of the shuttle's remote manipulator system, or the robot arm.
Box, bring me out away from the telescope while I reconfigure. I don't want to take a chance on hitting something.
Okay, Jeff, coming out. And I'll bring you straight out.
Yeah.
I'll hold here.
Okay. So this is serial number 1006.
Okay, copy that.
And I'm going to give myself a little bit of cooling since we're working here. And cooling is 2 now. Okay, Sox, let's come up
Going up.
and in.
Up and in.
Okay, now, can you give me a little bit of end effector, give me some end effector yaw? I'm coming in at a better angle. There we go. There we go. Okay, check once more. The pins look fine. Oh. Okay, keep coming in. Keep coming in.
Okay, my view's a little obscured here, Jeff.
I'm just starting. You're okay.
Okay.
Troy, the MFO is right behind you. Okay, stop.
Stopping.
You've got at least 2.5 feet, Jeff, if you want in further. You got 2.5 more feet to go. Yeah, but I'm okay. Okay. No, I cannot see the okay. Yes, I can. Sorry. You have to come in at a right angle straight. Okay, now I'm pushing down. You ready? I'm pushing up. We're ready. Go to Titan here. Okay, we're ready. Okay, here we go. Coming down. 1. Beautiful. 2. 3. Okay. Beautiful. Yeah, this one's a little more difficult because of the access. What's my back hitting, Story? Say again? I can't lean back. What's my back hitting? Let me see, Jim.
Endeavour is moving into sunlight as it moves across the southern tip of Florida on the 45th orbit of the mission.
That was, yeah. You're probably close to the door. It's not your stanchion, Jim.
Two astronauts are approaching 4 hours into the spacewalk. Again, continuing in the change out of the electronic control unit boxes. These boxes interface with the rate sensor units that have already been changed out.
How many total turns did you get tightening that one, Store?
I counted them, Tom, but I've forgotten. You were on 5, I believe. When you started to pop. I'd say 6.
Okay.
I guess I should remember them.
Yeah, it seemed a little less than we expected. It looks like it's down good, though, right?
It absolutely does.
Okay.
It's the same as the center one.
Very good.
And it came down smoothly.
Good job. One more to go.
Did it come in a little? Hold it a little. Okay. Are you ready? Ready. You'll have to count. I can't see. 1, 2, 3, 4. Coming up. 5, 6. It's riding on top. Do one more. Okay, stop. Ease this up so we don't grab any wires. Okay, you have it. I have it. Okay, now. Troy, can you move away so I can slide over so we can back out of here? Can you? Further over. Yeah, I'm trying to. Okay, looks like I'm clear. So let's pull back and away, Fox, and I'll reconfigure.
Okay, Jeff, coming away.
They're pulling me, too. Oh. Stop.
Yeah, I should. Need to go back.
Let's come back in and come forward a little bit.
Moving in and forward.
Let me turn around and see what's happening, Story. You're free. Okay. It was one of the, just a little patch caught on the material of your backpack. Okay, no problem. Okay, Zach, let's move away again. Let me just reconfigure. That the mag light?
Yep.
All right. What's it look like out here?
Affected in the dark.
It's not hard to see. This problem is when you're working in a tight area, like getting in those keyhole bolts, you know, because the helmet light doesn't follow a exactly onto where you're working.
Okay.
Okay, now we're going to be doing deck 1005. You know, the access in here, Story, is going to be tough. Yeah, it is. We're right up against the door.
Endeavour Houston for Tom.
Go ahead, Greg.
Tom, on ECU 3, we would like Jeff and Story to take the torque to 10 and try to get 3 more turns.
Okay, copy that. You copy, Story?
Yes. As Jeff said, it sure looks seated. Torque of 10, and of course it's multiplying. We're aware we're putting that torque of 20 on the box.
You copy that, Houston?
We're using the right angle, which about doubles the torque. So we'll be getting about 18 foot-pounds of torque on the boat.
That's correct.
Endeavour Houston, Tom, we understand you're using the right angle drive and you go to use a torque of 10.
Okay, we copy. You got to go for that, Story.
Okay. You don't want to see how far we go just with a torque of 5 first?
Yeah, let's that was ECU 3 they were talking about. Let's put ECU 1 on and see how many turns we get out of it with 5 before we work on 3 again. Is that okay, Houston?
That'll be fine,
yeah,
Tom.
We're sort of we're configured for the left one now.
Yeah, let's go ahead and put it on and count turns real careful on it. And I'm ready to go in when you are, Jeff.
Okay. So give me some more wrist yaw.
Okay. Got sunrise in 2 minutes, and it'll be top sun.
Okay. Story, if you can sort of move out of the way, and me get in position, and then you sort of squeeze in.
I think I am. I'm pretty
I think you're out of the way now. Okay. A little bit forward, Sox, as we're coming in.
Okay, Jeff.
Okay, keep her coming. Up about 1 foot.
Coming up 1.
Roll me forward. End effector roll. You got 4 feet of clearance on the MFR. Okay, keep coming in. You got 3 feet of clearance. Keep coming in. Stop.
Stop, man.
Okay, bring me down 1.
Down 1.
And your long extension is about to touch there. Okay, Fox, I got to come in. Bring me back up about 6 inches and roll me forward.
Okay.
Tell you
Endeavour
what,
Houston for
let's
Tom.
not move at all.
Go ahead, Greg.
ECU 3 is fine as is. They verified electrical continuity. No further action required.
Okay, copy. Good news. You copy, Story? No action on ECU 3.
We understand. It is seated. It's seated like the other one. Okay. Try to get my lights off.
Yep, and visor's down, probably.
The visor is down. Okay, Sox, drop me down a little. trying to get in, Jeff. Okay, I'll be right there. I'm pressing down. Be right there, maybe. Tell me when you want to start, and then I'll apply pressure. Okay, I'm ready. You ready? Okay, I'm pushing down. 1, 2, 3, coming down. 4, 5. No, it's not coming down. Hold it, hold it, hold it. Wow. It came down, it's been sort of riding on top. Okay. Oh, wait a minute. I'm in loosen. Oh, no wonder. Yeah. Okay. There we go. Okay. Let's try it this way. I got mixed up. And I was looking from the top. Yes. I got mixed up when I was on the 3. Are you ready? Let's go. 1. Oh, it's not going very fast. No. No, it's just 1.5. 2. 3. It's not pulling down. It's not pulling down, Story. Stop. Okay, let me push on it with my other hand. If I don't hold on to this quite as much, let me, Fox, take me up about up here 6 inches. Up 6. Stop. Stop it. Okay, let's try again, Story. Here we go. I can't. Coming down. 2, 3, stopping. Not down as far as the other ones. Sounds like, it looks like it's going straight. Let me pull back and take a look on this side. Yeah. It's in. The keyhole bolts are not tight. I can push it back and forth. Okay. You want to loosen it one turn and then pull it again, Story? Let's talk to Houston, okay? Houston Endeavour.
Go ahead, Tom.
Yeah, ECU-1 went down 3 turns and then popped the torque limiter. It doesn't look fully down either to Jeff and Story. It looks straight, and they've verified that it's not binding on the keyway bolt.
Okay, Tom, we understand.
They're proposing to loosen it a turn or two and wiggle it and try it again.
Nice and warm, eh, Story?
Yeah. And Story, did it seem like more torque than the others, the first 3 turns there?
No, the other one, the edge slowed down too. So this was comparable. But it's more torque than I'm used to.
Okay.
Did the other one go slower at the beginning, Story? Yes, it did. Okay. And it was intermittently slow. It was slow and speed up and slow and speed up. Well, my power tool was doing that on the keyhole bolts, and that's why I asked for a new battery. You know, it would slow down and speed up, and slow down and speed up. Okay. torque limiter. Yep.
What's your assessment, guys, as to whether or not the connectors would be making good electrical contact there?
I don't know how far in the pins go, Tom. It's about, Jeff, can you 3-4 millimeters higher than the others, than the other two?
Did you copy, Houston?
Have you been able to get your head right down and see how square it is, Jeff? If not, let me back off and let me. It's square. I was looking at it. It's coming down square. Okay, it really is. All right.
Endeavour Houston, Tom, we did not copy.
Okay, little added information. ECU1 is 3 to 4 millimeters higher than ECU 2 and 3. So it looks like it needs to go down another 3 or 4 millimeters. And it's asking them if they thought we would be making good electrical contact, and it's hard to tell how long the pins are in those connectors, of course.
Right. I can still see a few millimeters of plug above the surface.
Okay. Everybody's cooling, doing okay?
Yeah, I went up to 4.5 in the sun. I think I'm going to back off a little bit, though.
Endeavour Houston, Tom, we would like you to go to 10 on the torque limiter.
Okay, you copy, Story?
Yep. Do you want to do that, Jeff, or you want me to come off and do it? I'll do it. Okay. And we'll leave
Tell you what, Story, if you leave the power tool on 2, the power tool ought to quit about, a little quicker than the torque limiter.
Okay,
it's one notch in between. Do you copy, Houston?
You don't? Okay.
We copy, Tom.
I got you, Tom. Okay, go for it, Story. It's turning. It's coming down. Beautiful. All right, it slipped. It popped. Yeah.
About how many more turns did you get, Jeff?
Got about 3 more turns, and it looks down.
Super. So we got 6 on that one also. You copy, Houston?
We copy, Tom.
All right. Good job, guys.
Okay, and for the record, the torque limiter popped before the power tool stalled.
Okay.
Okay. Loosen up, Story. I don't have it. I've let go. Oh, okay. I must be pushing on it then. Okay. Okay. I have it. Excellent. Going back off and do a tool change here. The shock flips move out.
Going out, Jeff.
Yeah, you're clear of the MFR now, Story. Get my hook off. Return my cooling's on 3 now.
Okay, copy that. Let's see, Jeff. We're going to tighten keyway bolts, right?
Yes.
Yeah, we're
Okay,
working torque to 5, power
Right.
tool on 2. Agree?
Right.
And we want to use a cross pattern,
Stop.
right?
Stop.
Copy. And Jeff, just to make sure in there we're clear, torque of 5, power tool on 2, and a cross pattern, right?
Correct.
Okay.
aboard Endeavour, Jeff Hoffman and Story Musgrave appear to be just about complete with installation of the new electronic control unit boxes. These boxes interface with the rate sensor units to make up the rate gyro packages. They're about 4 hours and 15 minutes into the spacewalk this morning.
And get the 2-inch off of here. Okay, you got the tool.
And Kyle, I guess as they complete the ECUs here on that task, I guess we could say they're in terms of number of tasks, 2/3 of the way through doing the EVA, but the last task is some fuse change outs, and I believe, what do they have, 7 or 8 fuses to change?
Yeah, they have 8 scheduled.
Okay, and the fuses are originally scheduled, what was it, 45 minutes in their experience on the ground, so it looks like the repairs for today, the actual repairs, have gone reasonably well, save for the door, and there's still some talk on that particular portion of the problem that we've had today.
Yeah, and of course, and we've been monitoring some discussions that are going on offline as to what options there are available in terms of what to do about the door latches. But in any case, they're secure enough if we had to wait for another day to go back and fix those.
They'll be back in that area tomorrow when they do the, in 2 days when they do the wide field planetary camera, and that's right in the same area, so they'll be working around that portion of the telescope.
Take a photograph of him?
You bet.
This is pretty extraordinary.
I'll move away as soon as I get this on here.
Yeah, I'm going to get set up here. Move over to when you get off there, just go back to the telescope.
Okay. Got the tool change out done, Tom? Say again? You got the tool change out done?
Hold on to me.
Okay, sure. You're going to head back to the SAC, right, Store?
I got the telescope.
We like you up close here.
You do?
I see it firing.
Fired. Yep. Just bracketing.
Pretty bright, isn't it?
It is. One more.
Hmm?
And Kyle, those discussions on the door were several options, and basically some of the discussion involved as to when we can get to that problem.
Light off, it's so bright it's hard to tell.
Your helmet lights are off.
Okay, and yours are still on, you can get them later.
Okay.
But the suggestions to actually address the problem have included.
Since nobody is going to take a picture of the ECUs, I'll take one.
Good idea.
Thanks, Jeff.
I'm heading back to finish SAC prep. Roger.
Put the lock wire on the way, right?
You know, those suggestions about working on the doors have included actually unlatching the 2 bolts that are holding the door closed and starting over with the latch that they're having the problem getting closed, much like you're trying to align a box with 4 holes. Some folks might have had that experience. When one doesn't line up, you loosen the rest of them and then move that into position to get it lined up again. The other suggestion has been to somehow apply a little bit of force at the top of the door to essentially push the doors a little bit closer together. And some of the suggestions have been there's 2 handles at the top of the door, is to run some tethers through those handles and then and pull them together. The astronauts don't have the reach to reach both handles at the same time, and then use their arms and their hands to push the door closed. So that's why it hasn't been attempted to this point. There is somewhat of a concern as to how to limit the amount of force if you do start tugging on the doors with them both attached with the tether, but all that is under discussion, and I think the folks are coming close to a solution.
Yeah, it's obviously you want to be real careful in how you go about that task, and the consensus here in the flight control room is there's obviously no hurry, since the door is secure in the point that it is now, for them to go ahead and finish today's tasks, and then look at that a little bit further before making any recommendations to the crew.
And that statement certainly is true. There is no need to rush this. They have 4 other days with which to get back there, and then one day that even gives them the opportunity there will be working right in that area again. So if it doesn't get resolved today, certainly in 2 days we can look at it again.
Up in max on. Okay, Fox, let's bring me back in, and we'll close these. Okay, of 5, setting of 2, Titan.
Roger. And Jeff, if you can give me a distance estimate most of the time, it'll help when...
Okay, yeah, we're coming in about 3 feet.
Okay, coming in 3.
Well, the crew members are wrapping up the work on the electronic control units. In fact, closing up the door that's the protective door for that area. And Story Musgrave earlier, when he was getting a spare battery for the power tool, got the fuses, the 8 fuses that will be replaced. And those, the location for those again is over near where the rate sensor units are located, just above those.
3, 4, 5, 6, and it's switching. Now I come across the upper map. Is still behaving the way it was before. It sort of grunts and groans and changes its speed as it's running. So maybe it wasn't the battery.
Okay,
I don't know. 1, 2.
CL bolts are 10.
3, 3, 4.
Closing.
5. Okay, 4 keyhole bolts on 1006 on the right side. 2, 3, 4, 5.
W keyholes are down. Houston Endeavour. Houston Endeavour.
Go ahead, Tom.
Yeah, we got a spec 2
Tom, we're looking at that, and we would like the RSU survival heaters on now. Give us a mark when you do that, please.
Okay, we'll do that. And just now, as you were talking, the main bus volts came back up to 28.5 on A and B on spec 210, and we took no action.
We copy, thanks.
We'll be getting ready for fuse plugs or something. Okay, W's done. Tom, keyhole from central start 2 turns.
Copy, W done.
PDM handle coming up.
Alright.
And Houston Endeavour, the ISU survival heaters on my mark on 3, 2, 1, mark.
We copy.
On and talk back, Greg.
Okay, 4 bolts on the left ECU are torqued to 5. And, yeah.
Hey, copy, ECU 1, all 4 keyway bolts tightened and torqued, correct?
Correct. And if Houston's happy, I'll go ahead and close it out.
Okay, so you got both ECUs, correct?
That's good.
Okay, Houston Endeavour.
Endeavour Houston, Tom, just for your info, we got good continuity on both ECUs, and go ahead.
Okay, so we're going to close out Bay 10 door, and obviously we can't get the end effector video and this orientation.
Roger that.
Okay, Jeff, you got to go.
BDM handles installed.
Copy, store.
I know you can see. Take me down 1 foot.
Okay, down 1.
Okay.
Copy.
Okay, let's go up. About 3 feet.
Up about 3.
Stop.
Stopping.
Okay, the J-hooks all close nice and easy here. I can close them with my fingertips.
Great.
Okay, I'll torque them down now to 10. Cutting of 3.
Endeavour Houston for Tom.
Go ahead. Yeah.
Tom, we've looked at the data. We saw nothing wrong with main Alpha and main Bravo. So we don't anticipate any further problem there.
Okay, thanks.
One. You see that power tool?
Say again, store.
Watch the power tool working.
Yeah, I see it.
Yes, that's what they do. One. Three.
Endeavour Houston, further clarification, Tom. The stock cycled the DIU in preparation for the fuse plugs, and that's what gave you the message. Main buses are good.
Oh. Okay, thanks a lot.
Reset, let's drop it 3 feet.
again, Jeff?
Drop 3 feet for SOP. Down 3 feet.
What up? Did you say down 3?
Down 3 feet.
Okay.
You coming?
Okay. You're a little bit garbled, Jeff, so be patient with us.
Okay. That's good.
Take a look at your track bag there.
Yep.
Stopping.
Stop. One. Two. One. Two. The data clamp is verified long. Alright, I'm done with the solar array carrier.
Okay, store, and you said the SATA clamp lock is off, right?
Yeah, it is.
Okay.
How long have we been out here?
You guys have been really doing good. You've been out there 4.5 hours.
Real great. So, they're looking for useful work to do, right?
I'm sure they are.
Because I'm running out of useful work here. I need work to do.
Jeff's going to be heading over to do fuses in a minute, Story.
Okay.
Houston Endeavour.
Go ahead, Tom.
Yeah, just looking ahead, y'all got anything ready to pass on to us for the rest of the EVA after we finish fuses and Jeff gets the SAC prep stuff done?
Well, we're still looking at the doors, and we're expecting a flight note here shortly on that. We are interested in your observations from the aft flight deck on that gap, if you've seen anything over the course of this day pass.
Hang on 1 second on that, Greg. We're looking at it again.
Well, I guess I'm ready to move over to the other side of the telescope to the fuse plugs.
Okay, you're all done. We'll move you over to the fuse plugs.
And Endeavour Houston, Tom, just want to clarify for my own understanding here that the upper two latch bolts, if you tried going in with engaging at first, did you feel like you could make either of those two?
Negative. We made the handle latch with no problem, and the bottom one looks like will be no problem. The one right above the handle, which is the third one up from the bottom, is the one Jeff was working on trying to make from the beginning with a zipper effect. We've not even attempted the very top one because it's out the farthest. That's where the biggest gap is.
Okay, we understand.
Houston Endeavour.
Go ahead, KT.
Greg, we've been looking at that gap, and we kind of have a split decision up here, so I guess that it's not a measurable difference between daylight and dark. It's about the width of the crosshair of the 300mm lens on the ESC, and it seems to stay about that same width, give or take 10%.
I should have a look as we drive by.
Yeah, Greg, I think if we get Jeff to look right now, if anything, it looks the closest it's ever been together right now. If he could go take a look, he could tell us more quantitatively, I think.
Well, that would be great. Thanks.
Okay.
And Sykes and Claude, I know you're looking at how that array is drooping down toward you there. Only my perspective, I guess. Okay, let's bring me towards the door. Let's stop stop moving towards the port. Let's go into the door.
Stopping.
And up about 2 feet.
Okay, and up
We
2.
can drive about 3 feet in and up 2.
Hey, Mr. Tom, I got 2 hours of useful work. Do somewhere. Okay, Story, stand by. Guess if you want to, you could go fold up that port TA. We got to do that sometime, Story. Okay. Got anything you can offload in the airlock that would help you any?
Off 2 feet.
Well, I got the compliment I like right here. Okay. And your hands are blocked, Jeff, so the hand signals won't work.
Off 2 feet.
Hey, Story, why don't you head to the toolbox and pick up those things we were going to get day 1.
Good.
And I think you said stop, Jeff.
Well, I don't see very much change, if any.
Houston copies.
Okay, Jeff.
Well, there's still a,
And the top one definitely won't engage either, right?
oh no, neither one will engage.
If you check the bottom one just so we can confirm it will engage. And then we'll go do fuses.
I can see with my eyes that it will engage.
Okay.
Max, take me 1 foot down.
Down 1 foot.
Stop. Stop.
Stop it.
On the bottom latch and on the handle latch, the distance between the black seal and the body where the latch is joined onto the telescope is about 5 millimeters, 6 millimeters, both of them. When you get up to this one that I was working on, it's about, I don't know, 15. And the one at the top is about 20, 25.
Houston copies.
Okay, I guess let's keep riding around towards Sadie. That's right, the fuse plugs.
Yeah, okay, that's where we're going. And I'm going to start up and to port. I'm going to bring you out just a little too.
Houston Endeavour.
Go ahead, KT.
Are you configured for ESC?
KT, we are handed down to Diego. Wait till we get back up on the west in about a minute and a half. And then we'll be ready.
Okay.
getting to the point where I get a interesting view into the bi-stem up there. Maybe later on we could get a little bit closer and see if we see anything different from what we saw inside. Okay, we're at bay 4.
Astronaut Jeff Hoffman riding on the end of the robot arm, now being maneuvered over to the work site for the next task, which is to change out 8 fuse plugs, 8 fuses on the telescope.
We're ready to change out fuses. We have a go for bay 4.
Stand by 1. Endeavour Houston, we are still doing the commanding your go to open the bay door. Don't change out the plugs just yet.
Okay. Stand. Take me down 1 foot, please.
Down 1.
That's good.
Stop it.
And we're still torque at 10. Setting it 3. Loosen. Right direction. And go.
Endeavour Houston, KT, we are ready for your ESC downlink.
Okay, Greg, what I have is 6 frames. The first 2 are the second door bolt and the door latch at night. And the following 4 frames are the starting from the upper bolt to the bottom in the daylight. And maybe you can see some difference.
Okay, thanks.
Down mode 3.
Let's go up 3 feet.
Up 3.
Just a few minutes ago, Jeff Hoffman's was given a go ahead and open the bay door. That is the protective door above the area just to the upper right of the wide field planetary camera. This is where the fuse plugs are mounted. They're mounted on the inside of that door. And this task, in training anyway, took somewhere around 45 minutes or so.
And Kyle, and as we watch Jeff as he opens the door, we're looking at him through the elbow camera on the RMS, the remote manipulator system on the arm. But the view we're seeing gives you some sort of appreciation of the view that the astronauts have as they are maneuvered around on the arm as he looks at the telescope with the Earth in the background. That is quite a sight.
Doors coming up. on, right?
Yeah, why don't you go ahead and open the door, Jeff, please?
I was going to put a tether on it.
Keep bringing it on open, please.
Okay. Zach, pull me back just a little bit.
That's about far enough.
Okay.
Thanks, Jeff.
Yeah, you need to reposition to put that tether on, Jeff.
Yeah, bring me down and aft.
Down and out.
And as we know, Jeff, just a reminder, no more than 8 degrees.
Right. And this is interesting. Like we've seen sometime in the water, the upper J-bolt hooks are not circles. You can't put a tether on them.
Okay.
They're just U's, so I'm going to have to put it on the bottom.
Okie doke. We've been there before, right?
You know how to do it.
I missed it, Tom. I got 2 straight 6 inches. Copy. No problem getting the toolbox open, right, Stuart?
No, sir.
I had to readjust the PFR. It's a little high up if you don't put it down. Hey, I want a 10.3 straight 5/16.
That worked good, Jeff.
Yeah, I just have to know when you can see me and when you can't.
Sure.
And I want a 10.3 torque set tip, right, Tom? 10.3 torque set tips in? That's right. Good.
Jeff Hoffman attaching a safety tether to the door to make sure that it doesn't swing open any further than required for this task. The orbiter Endeavour on the latter portions of the 45th orbit of the mission as the orbiter approaches the southwestern coast of Australia.
Okay, we're tethered off at less than 90. Less than 80.
Roger.
Okay, let me get the 15.
And Houston, how we doing on a go for fuse plug changeout?
Not quite yet, Tom. We're still commanding. We'll let you know.
Okay, so we're standing by, Jeff.
Oh, okay, no problem. Hey, Tom?
Sir.
Give me a hand on the 5/16.
There is a wobble, but I don't see a straight. Okay, the new one is up where we took our one we've got inside here, the 5/16 wobble capture in the top hole, that new one that Russ made us.
Oh, it's marked with red?
Sir.
Wait.
Houston Endeavour referencing attitudes.
Endeavour Houston for Covey.
Roger, want to know if you're happy with this attitude since ECU changeout is complete, or do you want to go to the post-ECU changeout attitude?
What a great straight man. What we want you to do, Covey, is at 2339, go LVLH, and that will avoid having to do the maneuver at 0 even.
Okay, understand at 23 CLH, and that'll have us in the right attitude.
Yes, sir. Go, KT.
Greg, we've seen the solar rays seem to be slewing a little bit. I'd say they're maybe 20 degrees from zero now. At least.
That's a very well-calibrated eyeball you have there. It is 20 degrees.
So you already knew that, huh?
Yeah, we've been watching it. Evidently, that's the result of the work that Story and Jeff have been doing.
Yes, it's dipping down on the forward end. Okay, I'm getting the two French hook caddies, Tom.
We're looking at the DPC 9 amps message, Endeavour.
Roger, Houston. Okay, Store. How you doing there?
I think I got it all. I just picked up two French hook caddies. I got two French hook caddies. I got a standard caddy. I got the 10.3. I've got a torque tip, and I have two straight 6 inches. I think that's what you wanted.
That's exactly it.
All right. You got me trained.
Endeavour, Houston, your go for fuse plugs.
Okay, copy, go for fuse plugs. Jeff, you got it?
I'll be there in a sec.
Okay.
Jeff Hoffman's been given a go to change out the fuse plugs. Again, they're mounted on the inside of the bay door that he's already opened. The wait was to ensure that all of the electrical connections and the electrical power was disconnected, and that was handled from the Space Telescope Operations Control Center.
To follow up on your question, we see the slewing action on both solar arrays, and there's no concern there. We are going to clean that up before we do the rotate later, but nothing to worry about now.
Okay, we copy that, Greg, and now we see DPC...
7.
And no action on that either.
Coming back up.
No concern there.
Being powered off?
That's part of the load shedding associated with the fuse plugs.
Okay, thanks.
And Kyle, we see Jeff getting ready to turn in to start the fuse plug actual change out.
To yaw the end effector so that I can come in from a little better angle here, and then bring me up. Okay, up. Yaw to the left.
Up, your left.
Yeah. Let's come up about 3 feet. Hey, Tom?
Yes, sir.
You might ask Houston if there's anything they want out of the toolbox while I'm here.
We'll check, Tom.
Store, on your way in, put those in the airlock. You'd also go to the port PSA and get the tape caddy, or on your way by going in, your call.
Okay. You're coming up another 2 feet.
Okay, I'm watching the trims between the arm and the array on your left-hand side.
Okay, well, you're the ball for that. You mean up at the end of the array?
Correct.
Oh, plenty of room.
Okay, fine.
We have about 5 feet.
Okay, I take you further up, Jeff.
And that should be enough for right now. Let's hold it there. Stop. Okay. I'm putting the hook with the green grip, the green tether on it, onto C15 on PDU 1004, the upper left.
Okay, that's very good.
And I'm removing C15. And I'm going to put the new one on.
Just a reminder, Jeff, that there are hot pins on the fuses.
Understood.
And Kyle, as we watch Jeff get ready to change out the fuses, we could see the orbiter moving over Central Australia now as it moves into sunset.
Okay, Store.
Endeavour Houston for Tom. Suggest you pick up the tape caddy and the 2 adjustable tethers out of the port PSA while Story's in the proximity.
Okay, we'll do that. Copy, Store.
We're getting the MLI. What was the other thing?
Yeah, the tape Velcro caddies that we knew about in the port PSA, and they want us to grab the 2 extra adjustable wrist tethers that are in there also.
Okay. Tape and 2 wrist tethers. To determine the next one in, I have J15 from PDU 1002 on the upper right.
Copy.
Down 2.
Well, Mario, while we're watching Jeff change out these fuse plugs, you mentioned just a minute ago about moving from daylight into darkness, of course, and from your experience, of course, you conducted a spacewalk that lasted about 4.5 hours or so on an Endeavour flight in January of this year. And how quickly do you feel that temperature change when you go from daylight into darkness?
Well, Kyle, as I was making my comment on the temperature, I noticed Jeff was actually in the process of turning his temperature control down so that he wouldn't have any cooling. You feel the temperature change quite dramatically. It's rather sudden. It only takes about 30 or 40 seconds before you feel the heat of the sun or the lack thereof when you move into darkness.
And it's going to get dark in about 5 minutes.
And as we just heard from crew member Tom Akers inside the shuttle, the orbiter officially will move into darkness in about 5 minutes or so. He's been serving throughout this spacewalk as the coordinator with the 2 crew members out in the payload bay. And Kathy Thornton has been primarily responsible for downlinking in real-time photographs using an electronic still camera for evaluation by payload community and flight controllers here on the ground.
And Kyle, you bring up a good point. We noticed that the ground is already in darkness, but the orbiter, the shuttle, is not in darkness yet because of its altitude of better than 300 miles. Its sunset is a little bit later than those folks on the ground directly underneath it.
And of course, traveling at this speed, the orbiter sees about 16 sunrises and sunsets on each 24-hour period because of the speed at which the orbiter is traveling.
And those are rather spectacular sunrises and sunsets if you've ever seen the pictures.
Report GA is closed down.
Copy, thanks, Stuart.
Okay.
And Mario, I've got a feeling that the pictures don't do justice to what you actually see up there.
No, not at all. They don't, and it's all we have to bring back to share the experience with the folks down here.
Turn around and get the 60. Maybe you could take me away from the telescope just a little bit, Claude, so I don't
thank you.
do anything. Okay, that should be good. Okay. Okay, let's move back in.
Back in, Jeff.
And for P16s, I'll start with the lower left.
Okay, copy.
And I'm putting it at the very end of the closest to the clip.
Roger.
Okay, let's come up 1 foot. Up. That's good. Next one, next J16 is going to be on the lower right. And it's going in the second position, working back from the clip.
Copy.
Things all look good. Turning my light on.
Okay, lights on.
Visors up.
Visors up. Adjust your cooling if you need to.
I'm at the port PSA, Tom.
Okay, Storm.
up 2 feet.
Up 2 feet.
And let's move me outboard about a foot.
A foot outboard.
Yeah, that's good, outboard. Let's keep coming up.
Okay.
Actually, that's good. Stop there.
Okay, stop.
Okay, the next one is upper left. Going on position number 3. That's on. Finally, let's move up 1 more foot, please.
Up 1 foot. Stop.
Okay.
I got 2 adjustable wrist tethers. That's it. That's it, Caddy. Very good. I'll close out the PSA. Leave the stuff in the airlock.
That's done. Okay, let me just check each one of them that I've put in, make sure it's tight. Upper 2, they all look good. Let's drop down 2 feet, 3 feet.
Down 3 feet.
And Jeff, what one was that you were working on?
That was the upper right, that was the last one.
Okay, and that was the 4th one, right?
That's correct. And I'm just going and checking one last time that they're all tight.
Okay, copy that.
Okay, stop. Let's move me outboard and away from the telescope.
Okay. PSA is locked. Okay, store.
That's good.
Stop.
Okay, let's go back in. I'm going to take the tether off.
Okay, going back in, Jeff.
And it's night. I would have offered to take a close-out photograph, but I won't be able to get anything at night.
Yeah, that's correct.
Okay, so you're all done now, right, Jeff?
Yeah, I'm just going to get the tether off and close the door. Okay, stop, Clyde. Down 1 foot.
Down 1 foot.
Okay, Houston, fuse plug change-out's complete. You got to go to turn the circuit power on. All we got to do is close out the bay.
We copy that, and well done there.
Jeff, that took you a total of about 12 minutes once you got the door open. That was great.
Well, it helps to have practiced it a few times.
The report is that the change out of the fuse plugs is finished, and Jeff Hoffman's now preparing to close the door and relatch the 6 J bolts, as they're called, which secure the door in the closed position on the telescope.
So let's bring me outboard. Outboard. Just about a foot.
Just approaching 5 hours and 15 minutes into this spacewalk. As trained, this task typically took the crew somewhere around 45 minutes from start to finish. That includes opening the door, changing the fuses, and closing the door. The actual fuse change-out, as reported, took about 12 minutes or so, which is quite fast. And Hoffman, as heard mentioned, that's due to a lot of training. Again, he spent the most of any of the 4 spacewalking astronauts in the water tank.
For Tom, with our proposal on the half shroud doors.
Okay, go ahead.
While Story and Jeff are finishing up the rest of these activities, we wanted to pass on to what we think might help us out with the half shroud doors and let you think about it a few minutes here. If you're ready to copy, I've got several steps.
Okay, we're ready to copy.
Step 1 is to loosen the over-center handle latch bolt. Step 2, loosen all latch bolts to hard stop by hand only. We obviously don't want to repeat the previous problem with the other bolts. Step 3, position EV2 at the top latch. Step 4, we want to take the over-center handle to the position that optimizes, or I should say minimizes, the space between the doors. That's not fully open and not fully closed. That would be EV1, we think. Step 5, attempt to put, EV2 would attempt to insert the latch bolt in the bathtub with the top, the bolt at the top. Then proceed with tightening the latches if we can get that top one mated. If we are not successful in making that top bolt, we would like EV1 Tom, there is an option here we'd like to insert, which is if the top bolt will not make with that all bolts to the hard stop, we would like to try the second from the top. In other words, the one that has had the problem previously. If neither of those will make, then we would like to have EV1 go to the base of the telescope and pull down on the right-hand door handrail using what you can estimate to be 25 pounds of force or less, using your calibrated muscles, I guess. Meanwhile, Jeff should try to make either the top bolt or the second from the top. There is some indication here that maybe the door is slightly skewed and that pulling down on the right door might help in getting it fully sealed. I'll copy.
Beginning with step 1, we want to go loosen the over-center latch bolt. We want to loosen all bolts to the hard stop by hand. I assume you mean manually there. Step 3, position EV2 at the top latch and EV1 at the over-center handle, and take it to the optimum position that minimizes the gap at the top, and then EV2 will attempt to make the top latch, and if that's successful, proceed. If not successful, the next option is for EV2, to come down to the broken bolt and attempt again, the procedure above, optimizing the gap and try to make it. And if that's not successful, then EV1 will come down to the right-hand door and pulling down on it with no more than 25 foot-pounds, or no more than 25 pounds of force. EV2 then to attempt to make either one of the top two latches. Over.
Good readback, Tom.
Okay, and nobody likes the idea of, if none of this works, of Jeff taking that broken bolt out again and starting it from the engaged position, which it looked like he thought he might have been able to do.
Tom, I guess we misunderstood you earlier. I thought I asked that as a clarification, and you thought that that was not possible. If you think that might work, that's certainly worth talking about some more. Let us think about that while you work these other options. And again, we don't want to do this, and we don't want to do this until Story and Jeff finish the cleanup from the present activities.
Roger that. We want to go ahead and finish the SAC prep actions up on the telescope, right?
That is correct.
Okay, and Jeff, just to clarify, it looked like that was possible that you might have got it started from the engaged position, correct?
It would have given me about 2 more millimeters, which means it would have been very close. That plus maybe a little bit of pushing and shoving might have done it.
Okay. You copy, Houston?
We do, and that gives us another fallback that may just be the real solution here.
Okay. We'll press on. Thanks a lot.
Okay, I have 6 J-bolts tightened. Just going around and checking them one more time.
Okay, and Jeff, say again, you're working on the J-bolts, right?
I've got 6 tightened. I'm just going around and checking them one more time.
Okay, copy that.
Let's go down.
Okay, down.
Repeat.
Down.
Endeavour Houston for Tom.
Okay, go ahead, Greg.
Just to clarify, the hand loosening that we talk about on the latch bolts, that's using the Essex and just using, by hand, using the mushroom.
Roger that. That's what we thought you meant. Yeah, Story, copy. You got those tools all stowed?
Yes, sir, and I'll head out.
Yeah, I think it's going to work out real good for you to meet Jeff down at the SOAP, and we'll stow the ECUs, and then why don't you close the SOAP out, and Jeff can go start getting PFRs for the solar arrays.
Okay.
And Houston, Endeavour?
Endeavour Houston, just a reminder, 30 seconds from going LVLH. Go ahead, Tom.
Okay, thanks for the reminder. Yeah, Greg, we're thinking to give us more options tomorrow if you guys concur that we might put PFR in at each solar array today. That way we've got one in position regardless of which one we end up deciding to work on tomorrow.
Tom, given that was part of the plan for the easy tasks, you're a go to do that. We concur.
Okay, thanks.
Let's head down to the SOAP.
Okay, to the SOAP.
Endeavour Houston, we have completed the power up from the fuse plug change out, and we would like the RSU survival heaters off so that we can do the RSU aliveness test.
Okay, and we'll give you a mark when we do that. Okay, survival heaters coming off, ready, mark. talkback barber pole.
As Endeavour crossed the equator just a few minutes ago to begin the 46th orbit of the mission, making its way on a northeasterly track across the Pacific Ocean. Spacecraft communicator here in Mission Control, Greg Harbaugh, has just radioed up a plan for the crew to try to latch the doors properly that protect the rate sensor unit aft shroud area.
Yeah, it ought to be open, right, Store?
It's open. Just getting ready to close it.
Okay.
After you do what you're doing. Wait just a minute, Zach.
The doors, when the crew members completed the first task of the day, which was to change out 2 of the 3 rate sensor units, which make up portions of the gyro packages. Each rate sensor unit contains 2 gyroscopes. The doors did not close properly. The top 2 latches could not be reset after the changeout. So the crew went on and completed all of the other tasks scheduled for today's spacewalk, and in fact all of those have been completed. The electronic control units have been changed, and the fuse plugs have been changed, as well as preparations have been made for the change out of the solar arrays tomorrow. In fact, the crew will do some additional tasks in preparation for that spacewalk, and that is to install portable foot restraints on the telescope up near each solar array to save a little bit of time in preparation for that task tomorrow. So everything has been completed in terms of spacewalking activities today, and we're about at the 5-hour and 25-minute mark into the spacewalk. And that leaves some time now for the crew members to try this procedure to get these latches in place on this protective door. And again, this procedure was just read up to the crew from Greg Harbaugh, relayed to the spacewalking astronauts from Tom Akers, who is serving as the choreographer up on the flight deck of the orbiter.
Yes, Kyle, and as we watch the Jeff Hoffman get the old ECUs off of the arm to stow into the carrier for return to Earth.
Put these ECUs away.
I was just noticing that we are about 5.5 hours into the EVA, and this is the time that they'd normally be closing out the activities for the day, since we are a bit ahead of schedule due to the shortened time it took to do much of the changeouts, that is for the RSUs, the ECUs, and the fuses. Even with the door problem, we're right basically on time. And that'll give us the opportunity to do the closeout, do the extra tasks setting up for tomorrow, and also I think there'll be time today to make one more attempt at closing the doors.
And Houston Endeavour.
Go ahead, Tom.
Yeah, just for y'all keeping notes down there, you probably copied, but Bay 4 was completely closed out, all 6 J-bolts torqued down, and also Bay 10 on the ECUs was all closed out successfully.
We copy all that. Good work, guys.
And as Jeff Hoffman completes the task of stowing the old electronic control units, we just got word from Payload Officer Jeff Hanley in the room that the 2 new rate sensor units have been powered on. That is commanding that's done from the Space Telescope Operations Control Center that's located at the Goddard Space Flight Center in Greenbelt, Maryland. Again, the gyroscopes that are just being powered up, the new ones are part of the pointing and control system that basically holds the telescope very steady. In fact, to what's predicted to be an accuracy of 0.007 arc seconds, which is basically the equivalent to holding a laser steady on on a quarter, something the size of a quarter, at a range of about 200 miles. These new gyros are a new design which replace the gyroscopes on the telescope that are basically on based on 1970s technology.
Yeah, Greg, just to clarify for me, when Jeff starts doing the solar array prep, putting up the PFRs, do we want to go ahead and take the time to get both lock wires off, or do we want to leave that for tomorrow and go work the minus V3 doors?
Tom, our thinking is we want to try to ensure that we have time to do this door test, so we'll pass on the lock wires today, it looks like.
Okay, that's what we'll do.
Sliding these ECUs back into the holes is turning out to be a little difficult. I have the first one in there.
Okay, the RSUs went in okay, though.
RSUs went in fine.
Okay. And again, for the paperwork here, Jeff, we've got 1002 and 1004 we're putting up, right? That's too late.
Let's see. I can tell you that this one is 1002.
Okay, I got them earlier.
Endeavour Houston.
Go ahead.
Not to get you spun up, but we have 6 good gyros on the telescope.
Fantastic.
Okay, I'm sorry.
There we go. All right. Just a tight fit, but we got it.
Of course, Greg Harbaugh notifying the crew that the gyro change-out was successful. The check has been completed, and all 6 are in good working order now.
I can take it from there when you're okay, kid. I'll just bring that in. Okay? You ready? Yeah, you got it. You might hold it down while I get a J, when I get her, while I do a J. Yeah. Okay? Ready? Let's try to get the other side too together, Story, okay? Okay, this is easier. Let's go 3 feet off. Good.
Okay, 3 feet out, Jeff.
Houston Endeavour.
Go ahead, Tom.
Yeah, I'm sure y'all can see, but minus V2 continues to slew, and it looks like 30 degrees or so, and we'll have to start watching the arm operation around it.
We copy.
And then here where I can hold you. When you're ready. This would be hard. Okay, that's it. Okay, thanks. Take it from there. Okay. And that is a two-person job, closing this off.
Okay, and can you tell what's holding up on it?
I think it's just the door, Tom. You gotta pull, you know, about 25 or 30 pounds while the other person flips the J-hook over.
Okay, but I mean, is it the foam and the inserts inside that are sticking up anywhere that you can see? There's no, none of those Velcro straps out on around the edges, right?
I'll take a survey of the whole edge. I noticed as soon as I undid it, you know, it popped open.
Okay.
I opened it. No, I don't see anything.
Endeavour Houston, we copy the soap lid problem and further and we're looking at that, and to further amplify, the RSU aliveness test is 100% successful.
Fantastic.
Great news. Thanks, Greg.
Well, that's one new set of gyros for Hubble. That's great. It's not, you know, it's not impossible, Tom. You just have to push, so it's a lot easier with two people, and free floating it would be very hard indeed, if possible at all.
Okay, and while you were pushing there, we got a elbow slip, Jeff.
Yeah, well, I was pushing.
Okay.
Okay, I guess we need to go over to the PFRs.
Okay, I think you to base 10, Jeff.
And since we're doing the opposite sides of the telescope, Tom, I guess we might as well do it one at a time. Or do you think it would save time to get them both together?
All right, why don't you get one and work on it, and then when Story gets done at the soap, he can go configure the other one.
Okay.
And be able to hand it up to you. And it's going to get daylight in just a few minutes.
That's a 2 forward J-hooks.
Copy.
I've taken the long extension off my power tool.
Okay.
I just have the torque limiter on it at this point.
Copy.
If we'll have to reconfigure for the doors anyway. Okay, let's get the one on in bay 10 here. Okay, 4.5, that's perfect. Just bring me down now.
Okay, take you down.
And we're going to have to come inboard, and you'll have to check my clearance above me.
Okay, we'll check that. The battery's okay.
And for the record, this has been a very warm night path. I've been very comfortable.
Okay.
This has been working.
And we're LVLH now, so when it gets daylight, you're going to have a different view.
Okay. Inboard more.
Okay, inboard. want to be pitch down more, Jeff?
We just look. Yeah, I can't get to the. Okay, no, I'm fine here.
Okay, stop.
Okay, I have it. Okay, call out some numbers. Tom?
Jeff, let's have you run up and look at that crack on minus V3 real quick. It really looks a lot better right now.
Okay.
Is that okay?
Well, let me put the slip. Well, I'll carry the PFR with me.
Maybe you can pass by it on the way.
Okay. Okay, so you'll take me up by it, Claude?
Can't take you up now.
And you'll take me by the door, right?
Yes. And I didn't mean to interrupt you there, Jeff. You did get tethered to the PFR. Right?
Yeah, I am tethered. I should have called that, sorry.
Okay.
I got all 5 J-hook soaps closed down. What's your copy, Tom?
No, sir. What?
The soap is closed down, all 5 J-hooks.
Okay, copy, Story.
Houston
Whenever
copies.
you copy, soap is closed out, okay? Story, why don't you want to head back to that other PFR and I'll give you some settings for it.
On the FSS?
Yep.
Okay, on the way.
Story Musgrave just reporting a minute ago that he's completely latched the protective enclosure where the rate sensor units and the electronic control units were located. Again, as mentioned by Greg Harbaugh to the crew through our payload officer here in Mission Control, the complete package, the complement of electronic control units and rate gyro assemblies, the rate sensor units, has been checked out through the Space Telescope Operations Control Center, and the entire packages are all working as expected at 100% level.
Stop. Stop. No, I don't see any change time, just measured against the both heads.
Okay, I guess it just looks different to us at times. Okay, thanks, Jeff. Basically, we haven't seen any difference in sunlight or darkness then, have we?
That's correct.
Okay. Okay. Your choice as to which one of these you want to head up to.
Jeff?
I think we'd rather wait till daylight on this one on the left, maybe. Why don't we go up to the one on the right?
Okay.
Port one. Yeah. You can see how that minus V2 is slewed down, can't you, Jeff?
Oh, my goodness, yes.
Wait till daylight to work up there.
Yeah.
Okay, I'll take you to the port location, Jeff.
Okay, read me some numbers for the settings, Tom.
Okay. For plus V2, we want to be Nancy, Nancy. Alpha, Delta, Delta.
Nancy, Nancy. Sun. Already at Alpha.
Endeavour moving off the east coast of Florida. This is the 46th orbit of the mission as Endeavour moves from darkness into daylight.
Roll visor down.
Jeff, I go rather slowly here because of the small clearance between the arm and the end of the array.
You bet.
Okay, well, we'll play it by ear here. If we get too close for comfort, we may ask you to do that.
Okay. Okay, that's Nancy, Nancy, Alpha, Delta, Delta, and the number?
Number is 6.
6. And I'm ready for settings 2.
Okay, they're the same. 7. Nancy, Nancy, Alpha, Delta, Delta, 7.
Okay.
And we're going to go in 15 right, Jeff.
Okay. And this is going in 19, correct?
That's correct.
What, 15 left?
Endeavour Houston for Tom.
15 right.
Go ahead, Greg.
Reference your question on the solar ray slewing. We have been talking about that down here, and as long as you feel like you can work around it, we would like to not take any action there until we've completed the door work and the other basic activities. It requires us to go free drift, and we'd like to stay in this attitude as long as we can.
Okay, Roger, and we think we can work with it like it is.
Understand. Also be advised that you have until 0035 in this attitude for the door test that we sent up to you. If you don't complete it by that time, then we have another attitude we'll be giving you.
Okay, thanks.
That discussion by Greg Harbaugh with Tom Akers aboard Endeavour relates to the solar arrays. They've been slewing a little bit. They've been moving based on the work that the crew's doing on the telescope. So before those solar arrays are retracted after this EVA, the plan is to reposition those solar arrays, and that can be done by ground command from the Space Telescope Operations Control Center.
So it's aiming a little bit aft.
That's right. Should be toward the open side of the PDM.
That's correct. I got them all except roll, and I can't get
Okay.
unless I take it off.
Yeah, if you want to store, if you want to go ahead and take it off and practice putting it back on free floating, Jeff's going to be down there in a minute. You can hand it to him.
Okay. Let's go down and pick it up.
Okay, so Houston, PFR installed on plus V2.
You copy?
Tom Akers reporting that the portable foot restraint has been installed on the right-hand solar array, the solar array on the right side of the telescope looking toward the tail of the orbiter. That is work to get ready for tomorrow, and as the team likes to call it, that's considered useful work that can be done while the crew's preparing to do other tasks. So that's getting ahead of the work schedule for tomorrow.
Okay, Claude, we're ready to come down, pick up the other PFR.
Okay, we'll do that.
didn't get roll yet, Jeff. Okay. I couldn't get that one while I was on the thing. Okay, I have it. We got it. Hey, I guess we drive around to the other side.
Okay, I'll take you there, Jeff.
And this one, let's see, is Nancy, Alpha, Delta, 7.
Roger that, and it goes in on the left. 15 left.
Yep.
Now, you want me up by the minus V3 doors, Tom? Yeah, that's where we're going to be going next.
Okay.
Go up and look and think about doing is how easily you could pull down on the right-hand door. You could look for, any skew like that where pulling in one direction might help. To us, it looks like the crack is constant until you get up to about the final third of the door, right, Jeff?
That's what it looks like to me.
I mean, it doesn't look like a skew that increases linearly.
It's weird. Okay, this is going in number 8.
Roger that.
Okay, let's stop. Bring me in about 1 foot.
Okay, in 1 foot.
Endeavour Houston, useful work if Story could check the P101 while he's in proximity.
Okay, good idea, Greg. Thanks.
Okay. Okay, I'm finished.
Okay, looks good, Jeff.
Just trying to see if I can see the lock wire. Yeah, I see it.
Look like that inner loop's accessible?
I think so, yeah.
Great.
The bathtub's empty, Tom.
Okie doke. That's good.
Yeah, it is.
No trouble seeing up in there?
No, sir. Look right down in there.
Okay.
That's what it looks like. Okay, Claude, move me. No further down. Stop. Okay, let's come back up about 6 inches.
Okay.
I just want to scan all along the top again to see if I see anything unusual. All right, right at the hinge, the seal is touching the door. There's no... Okay, let's move around the front so we get in the middle.
And Tom? Yes, sir? I heard the numbers they want. I can put 100 pounds, or they want 25 to start with, right? Yeah, I think no more than 25. I can do the free floating right here. Okay.
Stop, move away. Stop. Move away. Okay, stop. Here's what I can report. The doors, the way they are now, there is a curved lip that comes around. It's the outside of a labyrinth seal of whip. Okay, now at the hinge side, the door is about at least 1 centimeter inside of that labyrinth seal. Behind it, the labyrinth seal protrudes in front of the door. By the time you get to the handle, the door is even with the labyrinth seal. When you get out to the center, the door is about 3 millimeters in front of the labyrinth seal, and it looks like the black seal up here, there's a little gap in it in front, which you've probably seen in the picture, right up above the bulb. It looks like somehow, let me try to get a light on it. It's really hard to see inside whether the doors are actually hitting each other behind. It looks like the gap goes all the way through. That's about all I can see with the doors closed.
Okay. Well, why don't we go ahead and press on with the procedure?
Okay.
So we want to go down and loosen that handle latch bolt, Jeff.
Okay. And that I guess I can do with the power tool. So I better get the Essex configured.
I forgot to have it because we want to do the final loosening we want to do manually with the muscle.
Right. So let me get that.
Story might come up and configure your Essex while you open the latch with your power tool, maybe.
Okay. Let me put it on the tether here. Let me turn it around for you, Story.
Okay. You're coming my way.
The other way.
Okay.
A lot of stuff on here.
Give me a ride. Okay, what you want on the Essex? Yeah, just that short adjustable and torque limiter that's right there. Just put them on the Essex. Okay, gotcha.
Yeah, put the long adjustable back on.
As reference,
Okay, let's come down.
Story Musgrave can be identified by no markings on his spacesuit, and Jeff Hoffman has a red stripe on the pant legs of his suit.
3 down and 3 right.
He's also distinguishable by a red stripe up on the top corner of his backpack.
Yeah, that's good. Stop.
Stop.
Okay, I'm going to loosen this. It should have been 23. Yeah, where does this retractable go? Oh, it's going back to my mini workstation. Okay, hang on to that because I'll use it for your ethics. So the one that I had attached to the Essex? Yes, good. Yeah, that comes back to my mini workstation. There. Clyde and Sock's been getting a workout on that arm today. Muscle, man.
It's a wonderful machine. Really works well.
Still been working on it, Claude.
And Kyle, you could see Jeff right now using the power tool as a manual wrench.
Really struggling.
And only go about 8 turns, Jeff.
This is a quite labor-intensive task when you start to think about that they've been out for 6 hours, and the hand is one of the first things to fatigue because it's a very labor-intensive thing to work against the pressure suit of the gloves. The gloves on the suit are like balloons, and if you've ever blown up a rubber glove, the fingers tend to stand up, and that's exactly what the glove is doing. So when you have to close your hand, you're working against...
About 6 turns on, and then it felt like it was getting a little harder, so I stopped.
Okay.
You're working against the gloves.
Well, really had a hard time getting it started. I had to do it mostly by hand, even though I used it to tighten it to 23.
Yeah, and let's keep track of turns, and I don't think we want to go more than 12. I think that's about the limit where we got in trouble before, Jeff.
Okay, now, Dory, how are you coming? I'm ready when you are. Here it is. Okay.
And Story Musgrave just passed the Essex wrench. Now, Capcom
23.
referred to the mushroom on the Essex wrench. That's that brass-colored circular portion, and that's installed on the wrench just to allow the EVA crew member to turn a wrench with a lot more facility than just a normal wrench like you and I use down on the ground. And as I mentioned, after 6 or so hours outside, the hands start to become a little bit fatigued. I suspect they're approaching that point at this point.
You're going to get to the very bottom one unless you don't think there's any problem at all latching it, right?
No, that's no problem at all.
Okay. And Houston, do we really need to take the bottom latch all the way out to the hard stop since it's engaging with no problem?
Negative, Tom.
Okay, so let's, I guess, go up to the very top one, Jeff, and bring it out to the hard stop with the Essex.
What I really want to see is if I can find out what it's hitting on. And what I'm going to suggest is that I'll do the procedure, but what I'd really like is for Story to look at what I'm doing from the inside when I try to close it, because he might see something that I can't see. That's something to consider. We keep one door open.
You mean with the left door, right?
That's correct. Another, well, that's right. The right door I can push inside the Wicked labyrinth seal with no problem. And the left door, well, the left door by itself I can also.
Yeah, okay.
It's when the two come together.
Understand.
a minute.
Okay.
Hold on a minute. I'm putting down my...
Can I help pull in any direction?
Yes, I think so, Story. It looks to me like if I'm just doing it at the top, I can get them to come together. So let me do that, and you hold the bottom.
Okay, let me go down. I'll go down there then.
It's out a little bit in height.
Don't you want me to get down and help?
I do. I want you to do the bottom, Story.
Yes, Jeff, I'm a free floater. You know, it takes me a while to get
I
on hold.
realize that.
Okay.
I'm just going to hold here. I think this may do it, Tom.
Okay.
Actually, Story, can you do the handle bolt?
And Houston, if you copy, Jeff's just working, putting the doors back together and thinks he's found a way that seems to close the gap. And we're going to try that, if that's okay.
Press on, Tom. If you've got a way to do it, do it.
All right.
So you got the handle bolt.
You want me to go up and do a tool change? Let's see.
No, just do it with the handle.
Okay. Yeah, see if you can just latch the handle, Story.
All right.
Take your time and get stable.
Yes, sir. I'm trying to.
Would it help for Jeff's feet to be in a different place, different attitude for you, Story?
I'm going to go over the other side. I can move out of the way, Story.
Jeff can roll left and...
It'll be fine here.
Okay.
No, it just takes me time.
We want you to take it.
This tells me there was no actual impediment to the door. It's as though the whole telescope has spread out a little bit. See what I'm saying?
Yep.
Right.
Endeavour Houston for Covey.
Go ahead, Houston.
Covey, in the off chance that we don't have this door troubleshooting complete by 0035, we would like to give you a new attitude to maneuver to starting at 32. That would be target 2, body vector 3, Omicron 180. Initiate track at 0032.
Pulled out here. Right?
Are you ready to do the handle?
No, don't do it yet.
Okay. Okay, Houston, copy. Target 2, body vector 3, 180, Omicron, A auto burn at 0032.
That's a good readback.
Leave it there. But I've got the top one in.
And Story, do you have the handle latch closed?
I'm about to. Oh, wait a minute. The bottom one isn't coming right. We got to go and work on that. So you stay here. I'm going to drop down and work on the bottom, okay? Pull it back, away from the telescope.
Okay, away from the telescope.
And then down about 6 feet.
And then down 6.
Okay, I'm going to try to get on the bottom bolt now. It's not closing. The doors aren't closing right. Let's try to get the bottom. Let me get the bottom coming in before you close that Story.
Okay.
Okay, do you want me to come on your left or your right side?
I can go either way. Is that how's that?
Well, it's probably easier for you to go to your right, because that way you're close to the handhold.
Okay.
Okay, 1 foot left, and I will have to pitch you down for clearance.
The plan here is for the 2 crew members to engage the 4 latches on the doors before they tighten them, and at this point the top one is engaged. Story Musgraves got the one of the middle latches engaged, and Jeff Hoffman's now moving to the lower latch to try to engage that latch.
Oh boy. This is hitting something, Story. Want me to release a little? This is hitting something. Yeah, relieve it. Yeah, I am. I'm totally relieved up here. This is hitting something hard. There it is. Oh, I see what it is. It's that striker plate. If we can pull it up, Claude, bring me up a little bit.
Okay, further up.
What we need is to pull up on this rather than down. Up and up some more.
Okay.
And to the right.
To the right.
How are you, Story? We're all right, Jeff. Okay. Now, wait, you got the handle there. Oh boy, I'm sure I made the arm slip there. Something the top went in has now made it hard to get this one in.
Well, if we took the bottom one out to the hard stop, would you have enough?
Well, the problem, Tom, is that the doors are hitting something hard now when I try to close them. I think we...
Keep an eye on your feet there, Store.
Okay, I'll tell you what I want to do is to open it up again, and so we can see what it's hitting. We've got to do this systematically. Even if I could get the lower bolt on now, I wouldn't want to torque it down because it's coming against something hard. I think maybe those striker plates are not quite mating because the telescope has pulled apart a little bit.
Okay, well, let's go back up and undo it, and maybe Story can kind of watch the bottom and get it adjusted first.
Okay, you want to try that, Story?
Okay. I haven't seen the whole problem. I've just got here, so...
Claude, let's go up about 10 feet.
Okay, up.
I haven't been able to see what's...
And Houston Endeavour, just to let you know what we're seeing now with the top door latch latched. The crack is uniform all the way up, but the bottom is not going all the way in. It's pushed out at the bottom like it's not closing. Jeff says it's hard down there, and there's a little gap at the bottom now also.
The gap at the bottom is 3/4 of an inch now.
Yep, just about like it was at the top before.
We copy all that, Tom.
Okay, now I'm going to pull in and try to release the top. Okay, now see if you can close the bottom, Story.
Okay, and which one?
Either one.
Okay. I see the little plate. That big groove, you see, has to go in.
Yeah, and that wasn't...
Okay.
I think what we really need to do is do it from the bottom and the top at the same time. So if you can put on your mini workstation on a handrail or something and try to push the bottom, and I try to push the top, maybe we can get it. And you may have to push up as well, which I know is difficult. Can you get the left door? Let's just see if we can get the left door. No.
Let me see. I got to work and get a position here.
left door fully in before we work on the right door. The other one, sorry. Okay, that one's fully in. You gotta bring me down, Claude. I've got to tether the handle out of the way. That's got... Oh, we're okay. It's floated out of the way. Okay, Story. Let's see if you can push that one in. No, the other door.
No. The left one here?
No, that's the right one.
This one?
Yeah. Gotta get that closed. Okay, good. Alright, now when that's closed, this one won't close. The top won't close. Alright, now the top is closed. Can you get the bottom closed? No, the other door, Story. Let's keep working on that door. Okay, now, just hold it in there. Okay, Tom, let me tell you what seems to be happening. And it might be these striker plates. Watch your feet, Story. When the lower part is closed, I can't get the upper part closed. Now Story's got the lower part back up. I'm going to open this door a little bit.
Jeff, could you drop down and get a little more purchase towards the middle of the door to help hold in rather than right at the top?
Well, I was hoping we could get the problem.
It's really hard for Story free float to hold in any length of time.
You can start gently with a PRD between the handle and the handrail.
Can you?
A PRD between the handle and the handrail.
As long as they were lining up, that would work.
I'm trying to see if we can get this one left door closed.
Okay.
Paul, drop me down 3 feet, please. Down 3 feet.
Down 3 feet, Jeff.
You know, when you're in like that, I can't get in. Let yours out, Story. Okay, now I can get in.
If we put a PRD across here, and you could start the bolts up there, and we could watch it go together, and I could just start the tension in with a PRD here. What do you think about that?
Well, also, Jeff, do you think that the procedure they sent up to us, that we might ought to look at that? Since top and bottom were both engaging there, right? Did we just need to pull them together?
No. It's coming up against a hard stop. It's as though those, I forget what they call them, the striker plates or...
The little triangle alignment guides.
I understand, but I thought the way we had it before, you think it was a hard stop at the top too, Jeff? It wasn't pooched out up there like the bottom was.
Well, I can feel it now with the door open. When Story has the bottom closed, the top door will not close. Let's try it with the right door, Story.
Go ahead.
Tom, in the high-fidelity mechanical simulator, they've had some success using the over-center latch, cycling that back and forth to help work the doors closed. If you could try attaching a bolt at either the top or the bottom and cycle the over-center latch and see if that brings the others together, that might help you.
Okay. You copy, guys?
Right.
I'll cycle the handle bolt then.
Okay. Bring it up
Store.
1 foot. Yes. Watch your feet.
Okay, up 1 foot.
I got it. No. Down.
Story to make that bottom latch for you, Jeff?
Want me to make this?
Yep.
Okay. Now, do you want want me to cycle that when you go up above?
You can, yeah. Okay, bring me into the telescope 1 foot.
1 foot in.
More. Closer. Closer. 1 more foot.
Okay. Okay, stop here.
It's up against a hard stop, and I think it's that plate on the inside. Open it up now, Story. Already the lower bolt has come off.
Okay, you want the bottom one back on?
I think so. Tell you what, Story?
Yes.
Try to put the bottom one on again.
Okay.
While the two spacewalking astronauts, Jeff Hoffman and Story Musgrave, continue to work closing this door, this protective doors on the star tracker assemblies and the rate sensor units, here in the flight control room, lead flight director Milt Heflin discussing with the EVA officer the time the crew's out, and that time currently approaching 6 hours and 20 minutes.
Tell you what, Story.
Endeavour Houston, 2 minutes to handing down to Diego.
I've got these ones partially engaged. Come get the center latch, Story.
But right now, this door...
The planning is to
Okay, there it is.
Okay, if you can keep holding that...
let the crew stay out as long as the to match the mission elapsed time that they normally would have come in, which would be somewhere around 3 days, 1.5 hours, which is about an hour or so from now.
I want to get a better angle where I can push more. So I bring it back a little bit and aim it for... We almost had it there.
Okay, we'll go up.
Yeah.
Now, you want me to hold in this door?
Yeah, I want to go back.
Door?
I'm going to get the center latch so that it's engaged but not closed. That was helping us. We almost had it there. Yeah, down 2 feet.
Down 3 feet.
2.
2 feet down.
Okay, now come up.
Up.
Okay, now I want you to pitch me forward.
Forward.
And bring me a little bit away from the telescope.
Yes, it's by the PRD on that handrail. In that handle, I could control very nicely the tension down here.
Okay, Brad, bring me into the telescope.
Okay, in.
Yeah. Into the telescope. Okay, Story, can you close it now?
Talking about the bolt.
What?
No, here. No, I gotta bring the doors together.
Well, I think maybe the PRD is the way to go then.
Yes, I think so. Then we can very gingerly apply tension.
Hey, Jeff, just so I'm clear here, if we were back to our original configuration, we could get one of those top bolts by some method, even though it feels like you're against something hard at the top. You think there'd be any light leak?
Yes.
The way we had it before, there was some light leak.
Yes.
Okay. Houston, you copy?
We copy, Tom.
So you agree with Story going to get a PRD just so he can control holding the doors together at the bottom to proceed trying to just maneuver and work them in?
That's affirmative.
Okay, Store.
Hey. I'll go very easy on it. We'll look at the door as we go. We almost had it that last time, but it just... But I think both of us have to be able to keep it held in, so I think the PRD is the way to go.
Endeavour Houston, Tom, we don't have clearance to use a PRD yet. We're working with the project to get that. In the meantime, Story can go ahead. Story can go ahead and get it.
Roger.
And you know, I'm only going to use hand strength with it. You know, Greg.
We understand.
Like 25, 50 pounds. Bring me down 2 feet.
Down 2 feet. Stop.
PSA, right, Tom?
That's affirmative.
Endeavour Houston,
maybe
Tom.
I could use this Essex wrench and take those bolts out to the hard stop. If that gives us just a little more clearance, it might help.
Again, Jeff.
I said, well, Story is getting that. Maybe I could take this Essex wrench and take the other bolts out to the hard stop, like they suggested. That might give us an extra millimeter clearance.
Yeah, I think that's a good idea.
Okay, take me down 4 feet.
Down 4 feet.
Okay, you went about 8 turns on those, so I wouldn't go more than 4 unless you can watch that screw.
I can't see the inside of it is the problem.
Okay.
Okay, stop.
Stop.
Endeavour Houston, Tom, the project is not comfortable using the PRD until they study it. So Story can come on back and see if he can help out without using the PRD.
Okay, Story, you copy?
I apologize for the extra translation.
That's okay.
But I can put on 10 pounds and get done what I otherwise can't get done. I could make, with very little tension, I could make that bottom bolt. I am not going to put more than 25 pounds on, but it's just hard free floating to do that. I'm not going to put any more on than I could with my muscle, but it's hard free floating to do that.
We copy all that.
You see, if it's going to take even tension, if we want to close the entire door with even tension and guide the alignment as we go, you need to put even tension up and down the entire length of the door, go down at the bottom and check if those guides are going in. With a PRD, you can maintain even tension, check the guides, be sure the guides are in, and you can maintain even tension the whole way, closing the door. I can't do that free floating.
Okay, taking you out, Tim.
We're talking about it, Story.
I think you know what I'm saying. If you try to close the door even, you need even tension the whole length of the door.
Stop.
Endeavour Houston, Story is go now for the PRD.
Story.
Okay, further up, Jeff.
You copy, Story?
Yeah, sure thing.
Okay.
And Tom, let me give you my opinion on the hard stop on these bolts.
Okay.
It does not exist. What there is a screw that goes into the end of the bolt. And so, obviously 23 foot-pounds was enough to unthread that screw. I'm not going to take it to a hard stop. I'm just going to put about 2 more turns on it.
Okay, copy that.
It's like going to the hard stop. We used to go to the soft stop. There is no such thing as a hard stop. The way, there's a little hole in the middle of the bolt. Yeah. And the bolt bolts into it from the other side. Well, what bolts in can unscrew. Yeah, we never liked that.
And Kyle's Story was mentioning it was very difficult for him to do the task that he's required to do, free floating. One of the things that we assessed on Greg Harbaugh and I when we did our EVA on STS-64 was to assess working in the payload bay with tools.
You need a PRD on your end too, or do you think just if I go to the bottom with one, we'll be all set? If we put it sort of in the middle of that handle, I can pull on the top.
And all of our tasks were free floating, and one of the things we did discover that all the EVA astronauts have discovered in the past is when you're free floating, it is very, very difficult to accomplish any useful work in space. You need to have something to react against, and just to give you an idea, is if Jeff were not attached to the end of the arm and he were using the power tool, as he pulled the trigger of the power tool, the chances are that with the socket on the bolt that he'd be trying to turn, that would stay steady and Jeff would rotate with the power tool in the opposite direction.
Fine. I ate my food bar, I'm drinking my water.
Copy that.
Yeah, the same. Roger. Doing very well.
So Story's comment about being able to react the force or not being able to react the force is very well taken, and having the PRD, the payload retention device, which is much like a flatbed truck come along, a small one if you will, to wrap around the handles of the door and pull them a little bit closed, apply the force that they need to hold the doors closed, and then at the top and the bottom they can push and pull or on the bolts to try to get them engaged. That is what they need. They essentially, if you will, if they had a third person out there, even that wouldn't do them any good, because even that third person there, he wouldn't or she wouldn't have anything to react against. So the strap, if you will, around the handles might be the answer here to resolve the issue.
And I think when the project heard Story Musgrave's description of how he wanted to operate that, they felt a lot more comfortable with him proceeding with that step.
Okay.
And the project was concerned those payload retention devices can exert quite a bit of force if you crank down on the handle enough, and the immediate reaction was, no, we don't want to do that, and indeed was the correct reaction. However, after hearing Story's comments, it allayed the fears that he wasn't about to do that, but just enough to get the doors to stay put with a bit of force on them so that they can get those latches over center there.
Okay, Tom.
Okay, we got lots of time.
You're down 4 feet.
Coming down for him.
I was not hurrying. I was just scooting along there. All right, Mr. Jeff, I've not seen all the problems.
Okay, let me... Okay.
But between, you show me where you'd like some nice, would you like nice even tension right here?
If we can get the sat coming in, and I'll push on the top, and we'll just bring it in slowly.
Okay.
The problem is that you know, when you just push on the top, then you can't get the bottom in, and if you just push on the bottom, then you can't get the top in. And when we had them both pushed evenly, we had no way that we could make the bolts, because we didn't have any hands left. Bring me down some more, 3 more feet.
Say that again, Jeff, please.
Down 3 feet.
Okay, down 3. Are you going to contact Story there?
Looks like my mini workstation is below him.
And Kyle, this is a prime example of how things in space can be very much different than on the ground. On the ground, this problem could have been resolved in a few short minutes by somebody just leaning against the door a little bit and pushing it closed, whereas in space, without being able to react with some force against something to push against the door, and with it free-floating, it can move in any direction. That presents a unique problem, an example of those types of problems we run into in orbit that you don't normally encounter in the ground.
I'd rather...
And of course, with this task, when this problem was first discovered early on in the spacewalk this morning, everyone already agreed that we could latch the middle latch and leave it that way overnight. And so they're off looking at all of those options as well. And the thinking now is that we'll give the crew another 15 minutes or so to work this before they have to clean up the work site, which is the payload bay of Endeavour, before heading back inside.
And even if the crew is unsuccessful at performing this task, that is closing the doors and buttoning it up for good tonight, all of the information we're collecting will give the people on the ground more information with which to work the problem and come up with a viable solution for the EVA in 2 days when they work on the WIFPEC. Or even they may send them tomorrow, but that remains to be seen. The planning shift will work that.
Yeah, I can go ahead and do that, Jim.
Okay.
And you could see in the just below the center of the picture what Story Musgrave is handling. That is the payload retention device. Has the beige or brown strap with some tether hooks on the end of it. It's just under Jeff's right arm, or Story's right arm right now. You can see it. Correction, Jeff's right arm was right the first time.
You put it charged for us.
Go ahead. I can put it on there. Okay. I don't like that. I'd rather have it, we put it on the strap there, or we can put it on the door itself.
Put it on the strap.
Put it on the strap? Maybe not.
But we might have trouble getting it off.
Okay, just put it on the, here. I can't move because the MFR's in my way. But, okay, do that.
That doesn't go.
Well, it'll go. I can't move because the MFR's in my way.
Let's go back.
I'll take you back, Jeff.
Yeah, I'll do her here.
Okay. I'm going to hold on to that.
Jeff, we're fairly positive that the star trackers aren't we're not even touching them, right, when we're closing in here. It's not
I've
that.
been looking, and I don't see the inside of the trackers move when we close the door.
Okay.
Now, could you keep tension on that so it won't fall off? Yeah, just keep tension on that hook so it won't fall off. I'll go the other side.
Houston, we powered camera D down. It was at 46 degrees.
We copy.
We may want to go around. Okay, let it get on. So we'll go around.
You got it? Okay.
Now.
Okay, now you go up above, and we put a little more tension on it, okay?
Well, I can do that, Jeff.
Okay, I just...
Okay.
Okay. Take me up.
Okay, going up.
Let's move out a little, back a little bit so we get away from Story.
Okay, I'll bring you away.
I'm going to use no more force than we would by hand. We can control. Will give us control to do what we got to do with the door while we put some tension on.
Story, you might want to go ahead and get your helmet lights on before you get in the bind here.
Okay. Put some cooling on too, man.
It's going to start.
Okay.
Ready to go in?
Yes, but here's how I'd like to do it. I'd like to go up another foot and pitch forward.
Okay, we can do that. Or I can kick your feet out if that helps.
Yeah, I want to be coming at it a little bit more horizontal so I can get more pressure. Okay, and you're going to have to bring me up a little bit and also back to my left. Okay, keep coming in.
All right.
Okay, that's good.
Stopping.
Okay, stay. Start pulling it in now.
Let me get some cooling on here. Okay.
And Story, once you get the bottom kind of going in down there, maybe you can use the handle latch to kind of zipper on up from there.
Yeah.
Okay. Now, Jeff, you want a little more tension?
Yes, let's start cranking it in.
Okay, I'm going real easy.
Can you see down there, Story, that it's going in right?
We're not quite far enough in to even check yet.
Okay.
Now I'll bounce down there.
So good up top.
Okay.
And remember, Story, the door on your left has to go in before the door on the right.
Yes. Okay, we're doing fine. They're both clear.
Okay,
They're
and
both doing well.
they're both clear up top.
Okay.
So bring it in a little bit more.
Endeavour is currently moving off the northern tip of Australia on the tail end of orbit 46 and beginning to pass from daylight into darkness.
Much it came in a little.
Well, I just brought it 1/4 of an inch. Now the gap at the bottom, Jeff, is 1/2 to 3/4 of an inch.
Yes, and at the top too. Now we have to try to push them in together.
Yes, and the doors are even. They're okay down below.
They go in up top.
They're on the guides.
Okay, now let's use the handle, guys.
See if you can use the center handle.
Bottom doesn't look good, Store.
Well, we can't back this handle bolt out anymore, right? It's all the way out.
Now, we didn't take it out the extra turns, did we, Jeff?
I think we should take that bolt out all the way.
I didn't back that out any. How's the bottom looking though, Story? Is that in?
Let's go look at it.
Go back down and let's work on the bottom.
You want me to release the handle bolt?
Yes.
Now the bottom is good. You want me to PRD a little?
I want you to pull the PRD in a little. First check the bottom. Make sure it can go in.
I did. The bottom is fine.
It doesn't hit a hard stop.
No, it does not.
Okay, pull in a little bit more. Okay, let's try it again.
Go back and check the bottom.
The top is okay.
Bottom's looking better here.
I can feel it on the top now, sliding on that plate. We're just on the hairy edge. How does the bottom look? It's good. Does the bolt fit over?
Endeavour Houston, again, we'd suggest you cycle the over-center handle to help work it in.
Yep, that's what we're doing.
Does the bolt?
That's what we're doing.
Wait. Does the bolt fit over?
No, it is not.
All right, one more on the PRD.
I want to cycle the handle bolt a little bit.
Okay? Yeah, see if you can engage the handle bolt, Story.
What did I do to the bottom? The top is in.
Just a second. Now I got to get that seated. Okay, let me get the tip pin in. It is engaged.
Yeah, it's looking pretty good at the bottom, I think, Story.
The top is in.
Yes, I'll get the tip pin in. I'll do a free floater dash. Okay, tip pin is in.
See if you can engage the bottom latch, Story.
Okay, bottom looks pretty good.
The bottom is engaged.
All right, guys. Houston, I think we got the door closed.
Yes, and the top is engaged.
All right.
Good work, guys.
Crew's reporting that they have all of the latches in place. All that remains is to tighten the bolts now.
Okay,
Start with the handle bolt, right, Jeff?
yes.
Hold on.
Good job, guys. Story, if you want to grab the PRD and get the TA.
Well, let's leave the PRD on for a minute until we get everything latched up here.
Just a second. The handle bolt fell off. I'll go get it.
Well, I'm going to go and work on that, Story. I have to tighten it now.
Oh, it fell off.
Oh, okay. It's okay.
But you think we're all right? You think I'm free to leave?
No, I want you to stick
around.
I want you to stick around until we get it put together.
Just
Got them all engaged now, Jeff?
Yeah, but they're pretty loose because of the PRD.
Okay.
And I want to go get the handle bolt and tighten that up.
The handle's engaged with the pip pin, right?
Yes, but it's not tight. It floats out.
Okay.
Okay, Story, if you can just move over to the side and Okay, let's take me down 4 feet.
Down 4.
Okay.
Stopping.
Let's get the tip pin back in. That's good. Okay, the tip pin is in. Okay, it's starting to drive a little bit. I'm going to do them each a little at a time. Let's go up. 1 foot and left 2 feet.
And torque 23, right, Jeff?
Well, not yet. I just want to get them in. Yeah, I mean, I'm setting it toward 23, but I'm not taking them all the way in. I want to just do them a little bit at a time.
Okay.
Okay. Up another foot.
Up 1 more.
Stop.
Stopping.
Okay, let's go all the way down to the bottom.
All the way to the bottom.
Stop.
Stopping.
Okay, let's go back up. And Tom, this power drill doesn't have enough to push 23, so I'll finish it off with the Essex wrench.
Okie doke.
Okay, I guess, you want to borrow my power tool? I can try. I think the Essex is just as easy at this point. All right.
Hey, Jeff, now the first one we want to torque up's the handle, right?
That's right. We're going up too high. Let's drop back down 4 feet and come to the right.
We want to make sure the handle stays ahead of the others, right?
Yep.
Okay.
And none of them are really... Okay, stop. Let's come 3 feet to the right.
How's that, Jeff?
Okay, let's go up.
Going up?
Well, I think we got it, if you want to take the PRD off. All right, Tom, you want me to close things out?
Yeah, when you guys are ready, we're ready, Story.
Okay, I'll pick up the PRD and stop. I'll get the PA left.
Roger that.
We've left no tools anywhere.
That's affirmative.
Except where you're supposed to be on the carrier.
Yep.
Stop.
Jeff Hoffman and Story Musgrave wrapping up, tightening the bolts now on the protective doors for the rate sensor units and the star trackers on the telescope. this completes the assigned task for the day.
Stop it.
And all that's left for the 2 crew members is to do their daily cleanup activities and climb back into the airlock.
Stop it.
Up 1 foot.
Up 1.
Let's start coming down again.
Okay.
Stop.
Stop it.
I got your feet straight.
Okay.
In fact, I'll hold on to you. All right.
And Houston Endeavour.
Endeavour Houston, go ahead.
Yeah, Greg, Jeff's going to finish torquing up all 4 of the bolts with the Essex wrench. Torque at 23. Story's getting the PRD, going to get the TA, and we think then that we've got everything cleaned up and ready to head in.
Well, I'm going to have to get the star trackers, too.
That's right.
That's right, we want to get the Star Tractor shades. Other than that, we agree, Tom.
Copy that.
Yep.
It's, you know how tight it is on that handle there.
I do.
Gonna take just the right geometry to get it out of there.
I'm holding on.
And Endeavour Houston, one other note for you on the timeline. Because we're going to have to do this additional solar array slew, we could very well find ourselves using the backup rev for the SDM retraction later this afternoon.
Roger, understand.
Want me to try it, Story, from the top?
That discussion related to the slew of the solar arrays during the EVA this morning. The solar arrays have moved slightly, and before the HST project folks can retract the secondary deploy mechanisms on the solar arrays need to be moved back into the proper position. And so once the crew is completed with the work on the telescope and is moved back into the airlock, that slew procedure can take place. However, it may take place about an hour and a half or so later, the actual retraction, than planned.
Want a little more?
No, it's okay. Good. I'll hold it. Good. Thanks. Yeah.
In fact, the flight team had a placeholder in the timeline in the event that something like this had occurred.
Okay.
Okay.
Adios for a while.
Okay.
Okay, I have a torque of 23. Okay, can you correct my pitch, bring me back so that I'm vertical again now, please?
Sure, and I'll take the rollout too if you like.
Okay. Well, actually, just get me vertical. Don't worry so much about the pitch. I mean vertical and roll. So I'm along.
Okay.
Okay, very nice.
Hold it here.
And bring me in 1 foot.
In 1.
good. Take me up to the next bolt, about 2 feet. Up 2 feet. Okay, and in 1 foot and left 1 foot.
In 1 and left 1. Great job when it got right.
Stop.
Stop it.
Okay, got 23 on that. Let's come up to the top bolt.
Go ahead.
That's good.
Stop it.
Better be careful with the wind break here.
Copy.
Starboard gear is done.
Okay.
Okay. Let's go all the way down to the bottom.
Going down.
Stop it. Okay. Go. I thought I had the wrench free. I didn't quite. Okay, let's get the bottom one.
Okay, you ready now? Okay.
Yep.
So the HST toolbox was all closed out, right?
Yes, sir.
Okay.
And the PFI, all of it.
Okay.
Another foot. Keep coming. Keep coming. Stop.
Stop it.
Jeff Hoffman and Story Musgrave just moving through 7 hours into this spacewalk, having now completed all of the task and closing up the door, the protective door on the compartment that houses the onboard star trackers and rate sensor units for the Hubble Space Telescope. Story Musgrave is completing the cleanup activities in the payload bay that's required each day at the conclusion of the spacewalks, and soon the two crew members will be moving back into the airlock.
And Kyle, you mentioned the 7 hours. It sounds like it's getting close to the record is only an hour and a half away. Story and Jeff won't be out there that long, but the longest EVA to date was 8 hours and 31 minutes, I believe, is the time on that.
Yeah, Jeff still has.
And at this point, 7 hours is a long haul for these two.
I'm just hanging.
Yeah, they've certainly trained for just such contingencies, and being able to stay out longer in the suits certainly have the capability to do that. I guess you have a lot of insight into the amount of time you have. Not in addition to your regular backpack, you also have some reserves if you need them.
Well, there's lots of reserves, and the margins for the suit are considered with that in mind. So and usually you consume the consumables, the oxygen and the water for cooling and the battery power at less of a rate than what they're designed at. So that always buys us a little bit of time.
Right over the Hawaiian Islands and a little bit over the Baja in southern Mexico and just across the Gulf, just so you know where you are.
All right, Carl. Thanks for the ride. Okay, let's come up.
Going up.
2 feet. Left 1 foot.
Left 1.
Endeavour Houston, 2 minutes early handover.
In 1.
You mentioned the time frame. Normal training during the training sessions in the WETF is they're about 4 hours generally, and Jeff, Story, Tom, and Kathy have been training generally for 6 hours at a time on each run. So they are well conditioned over and above what we normally do, and also when you're going out, it's what your expectation is. If they were going out with 6 hours in mind, so an extra hour really isn't that much more. However, if they had gone out with the 4-hour training, like I mentioned, and then added on 3 hours, that would have been a big difference. And then certainly they would have been a lot more tired than they probably are at this point.
Thanks, folks.
Based on your experience, your flight, your EVA was somewhere around 4.5 hours. What would you consider in terms of fatigue? Did you get fatigued in the fingers? We've always heard in training that the fingers is the most intensive part and the part that gets fatigued the quickest.
Well, the fatigue factor comes in basically in the hands. That's where you feel it the most. You don't really get cardiovascularly fatigued in the sense of the athlete who is jogging a great distance where he runs out of steam. That's certainly not the case. They have a lot of reserves. Their heart rates generally stay down, elevated above normal activity levels, but not much more than that. But in the arms and the wrists, and particularly the hands, and in my case, it was in the fingers and the thumbs down to that extent.
I guess most of the tasks associated with the Hubble repair are not really hand or finger intensive by design. Most of the telescope components are to be changed out by tools, and so the real hand intensive tasks are minimized on this flight based on all the training and the design of the telescope.
Well, the training tasks and the design of the telescope certainly made it a lot more easy to do the tasks.
And then if we need it, and that keeps one less thing in the airlock.
Okay, I'll put it away in the PSA then.
Okie doke.
And as you recall, on STS-54 we had the first in the quote generic set of EVAs, and then STS-51, 57 most recently. And during those EVAs, we refined some of the techniques to the point where we would want to minimize the type of fatigue that we used to experience. And so there was a learning curve, and with the data collected on those flights, it certainly helped improve the efficiency with which we do our tasks.
And I gather that the knowledge that you brought back was certainly passed on to the next EVA crew and the next EVA crew to pass on down to this crew to help in the training process for this particular flight as well.
Well, certainly it was an iterative process. We had gathered what we could when Greg and I had gone outside from the experienced EVA astronauts. We took their advice aboard, and in a more systematic way, our flight and the subsequent ones put it down in writing and in paper and documented the things. For example, one of the things we were trying to do is timeline better from the ground to space, because of the differences we talked about earlier that you encounter in training in the pool, if you will, the weightless environmental training facility, and in space. And certainly, as in this EVA, it was evidence that the guys became really efficient. For example, the fuse change that Jeff did was allotted originally about 40 minutes, 45 minutes, and the actual time that he spent in changing out the fuses was 12 minutes, with the overhead of opening the door and closing the door. That wound up coming to about half the time, about 20-25 minutes. So, with practice and efficiency, you cut the time down in half, and that is the goal, is to so that you're ahead of the game when you get into space rather than behind the 8 ball.
Well, it certainly helps, and Mario's mentioning Greg Harbaugh. Of course, Greg trained with this crew as a backup spacewalk individual in the event that one of the 4 that are up in space now couldn't go. He trained as a backup crew member. He's now serving as the spacecraft communicator here in Mission Control throughout all of the EVAs.
Yeah, and Greg, from the ground perspective, is probably the most familiar person with what Tom and Kathy and Jeff and Story are doing as we go through these tasks, because he's actually worked them in the training facilities down here on the ground.
Okay, let's come in about 2 feet.
Going in.
Okay, stop. Let's do
Stopping.
Port 1 foot, and we'll be there. Good. 3.
And Kyle, you notice Jeff is going from one bolt to another as he tightens these up, much like if you're putting on a tire on a car and you're tightening up the lug nuts, you don't want to tighten them all up from one side and go around in a circle. You tighten them off in a staggered fashion, and that's what he's doing so that the door gets the force applied evenly across the door and smoothly. So it's taking a little bit longer to get this sealed down than you might expect, because he's moving alternately from one bolt to the other, tightening it up a bit, and then going on to the next one. Ultimately, he will reach the 23 pounds of force that's needed on each of the bolts, the torque requirements. And when that's done, the task will be complete, and the guys will button it up and come in.
Take me to starboard about 1 more foot, please.
Okay, 1 foot over to port. Yeah, okay. Probably point in the right direction.
Okay, thanks, that's good. I want to be able to see the bolt. 1, 2, 3, 4, 5, 6. Half the lower left now. 1, 2, okay, pull back about a foot.
Be okay. 1.
That's good.
Stop it.
1, 2, 3. Okay. And 5.5 on all of them. Star tracker. Door shade seals are closed up. All time, am I ready to head for home?
Okay, you've confirmed 3 bolts on each of them, right?
Yes.
Sounds good to me. And Houston Endeavour, looks like the Star Tracker seals are completed, and Jeff's going to head this way. And you copied Story. He's going to put the PRD back in the port PSA.
We copy all that, Tom.
Okay, and Jeff, on your way, I'll talk to you about what you want to bring in when you're ready.
Okay. Let's start moving back, Zach.
Hey, Jeff, you want to make one last trip around the door seal edges and look at the minus V3 doors?
That'd be a good idea.
Must have hit it with a mag light?
Yeah. Zach, we didn't really look at the top and the bottom. Okay, let's do that. Let's drive up. Inside. Okay, let's just move along the seal.
Okay, coming to port.
Okay. Yeah, it's nice and tight now. PSA is closed down soon.
Okay, copy that, Store.
And I'm heading for the airlock, right? Okay, let's go down. Going. Get my safety wire.
And the shade seals all look good too, right, Jeff?
The shade seals are clean, yeah. They're right pressed up against the door, just like they were when I came here.
Great.
Okay, let's move back a little. Bring me down a little lower. About one more foot down.
Okay, well, I'll pitch you down, Jeff. We're real close on the wrist there.
Okay. Well, I'll tell you what. Wait a minute. I'll just turn around. I can get down like this. starboard. We'll go along the bottom of the seal in the other direction.
Okay, here we go.
Well, it's nice and clean from the underside.
Go up the last hinge there.
Yeah, just come in a little closer. Okay. Okay, it looks good all the way around. I think we got a good feel.
Okay, sounds good.
I closed out the slider, Tom. I'm on my guy wire.
Okay, Stuart, thanks.
Okay, now I'm going to have to take my Essex wrench back apart and stow that back on the board because we're going to leave that outside, right?
That's affirmative. And KT said just leave the short adjustable on the Essex if you want to.
I can do that and just put it in the little. Hey, Tom.
Oh, excuse me.
Hey, Tom.
Or Greg, you want me to look at camera A while I'm right here?
Say again, Stuart.
Do they want me to do anything with camera A while I'm right here?
Let me ask Stuart. I'd forgotten about that.
That's a
Houston
negative.
Endeavour.
Negative, Tom.
Okay, negative, Stuart.
Right? And let's see, the only question on the Essex wrench for Kathy, you want it to, does Kathy want it in the same direction that I have it? Remember we talked about that, Tom?
Yeah, I think we need to bring it in, Jeff.
Okay.
She wants it the other way.
Okay, in that case, I'll just stow the short adjustable.
Endeavour Houston, free drift for a slew, please.
Copy, Houston.
Do I have to lock the guy wire reel or not?
Yeah, I think we ought to, Stuart.
Okay, let's just check.
Okay, and hey, Zach, while I'm still working on the tools, let's not get too close to the solar arrays because everything is going to be flopping around.
Okay, Jeff, I'll keep you up a little bit then.
I locked off my guy wire.
Okay, Stuart, thanks. And I guess you're in a position to take a handoff from Jeff, right?
Sure. Yeah, sure can.
Okay, I'm going to take the torque limiter with the short adjustable and put that back on, okay?
Okay, Jeff, that's a good idea. Give a full test on that.
The sun coming.
And lights off. Visors.
I don't. You sure had good suits today, Tom.
You bet.
Endeavour moving from darkness into daylight as the orbiter moves across the Gulf of Mexico on the 47th orbit of the mission.
Okay, let me also take my long adjustable and put that back on the board.
Okay.
I'll leave that up.
And Kyle, I just heard Story made the comment passed to his crewmates that we sure had good suits today, and that's an important factor in an EVA, is having a good suit fit. And the real test of a good suit fit is after the end of the EVA, is how it still feels. And after 7 hours and 20 minutes or so, if Story's saying that he has a good suit fit, those suits are well or fine-tuned for their use at this point.
Well, it's obviously good news, since they'll be using these suits on the day 3 and day 5 of the 5 scheduled spacewalks.
Yeah.
Stars are great today.
Okay.
Mr. Clyde. Clyde was great on the arm.
Story, you did great.
Well, there isn't anyone I'd rather hear it from.
Okay. Now.
Hey, Jeff, and we'll want to bring the trash bag in.
Yep.
And Kyle, with this good view from the elbow camera, you can see Story up at the forward bulkhead, just at the windows, talking to his crewmates. And this is one of the things that all EVA crew members like to do. They try to get up to the window to get their pictures taken, if you will, and kind of their proof to take home that they were outside. Of course, this is the first time they've had the opportunity to take a break. At least Story has. They've both been working pretty hard.
Just a hand in, and then this fish stringer, I guess.
Okay. I was just going to put everything together.
Okay, you think you put them all on one thing, Jeff?
Well, coming in is easier than going out.
Okay.
And I got enough hooks. You can do what you want, Jeff.
I'm easy.
Okay.
Okay. Let me get the ethics on it.
And we want to bring that used battery in, too?
Yep, that's on the stringer.
Okay.
And I think the 80-inch tether that I used, I think I'm going to bring in so we can refold it. How about make it nice and pretty?
Okay.
Right. Okay, moving over to the other side.
Oh, my goodness.
What?
Looking out the front,
sun coming up.
Yep.
Okay. And now, the camera, I'm going to hand the camera in separately, maybe, Story. Okay? And I guess the thing we need to do is to talk about what should be left.
I'm ready to tell you when you're ready. Billboard 5 ought to be empty and have 2 retractables on it.
2 large, small retractables?
You ought to have 2 of the... You're going to have 4 total, 2 on each billboard. One will be a small.
Okay. And Tom, they really don't want anything on camera A? I'm right here.
No, they said they didn't store.
Okay.
And Jeff, I tell you what, leave one of your big tethers so you'll end up with 4 big littles and bring the small one in for KT. So you bring 2 smalls in.
Okay.
So that's all that ought to be on billboard 5, 2 retractables.
Let me put a big small on it.
Endeavour Houston for Tom.
Go ahead.
One note for you on Jeff's battery lifetime. According to the software calculations on his DCM, he'll have 30 minutes left. In about 10 minutes, he'll get a message. He can disregard. He's got a lot more time than that.
Okay, copy. Do you copy, Jeff?
I do.
Okay.
Okay, now let me get my gloves. Didn't have to use them, but it was nice to know they were there.
Roger.
Endeavour Houston, the slew is in progress. You should be seeing motion.
Hey, we're watching.
The slew mentioned is to reposition the solar arrays, put them back in a vertical position relative to the telescope in preparation for the retraction of the secondary deploy mechanisms. That's the window shade type retraction mechanisms on the solar arrays. And that, again, will be done a little bit later this morning after the crew gets back inside.
Okay, now the needle nose and the cutters, I guess you want to leave on?
Oh, we need to bring those
Bring
in.
those in. Okay. Oh, that's right, we got to reconfigure.
Yep.
Sorry, couldn't get it for you, Tom.
That's okay. I was wanting to do it anyway.
I knew you were. Take another look. We have on toolboard 4, also 2 large small retractables. Let me check the back of it. Just has the torque limiter and the short adjustable.
Roger.
And the only thing I have left on there is the Hasselblad. So I guess we're about ready to head down.
And we need to leave, if we can, 2 wrist tethers on there, or we can take them back out, Jeff.
I'll be glad to leave them on there.
Okay. One should be an adjustable and one a regular.
Okay.
And Tom, my safety rails on the forward bulkhead for Jeff to pick up, and on my right waist tethers to the airlock.
Okay, Story. Sounds good. And sticking out there to take hand off of stuff?
Well, I got a bunch of big hooks.
Oh, okay. Yeah, I see you down there now.
After I get it, that's another mirror. But I always got a big hook.
Endeavour Houston, Tom, we want to verify you're bringing the Hasselblad back in.
That's
That's
affirmative.
affirmative. You bet. Yeah, Jeff, they're looking at their tool setup cue card. The only things we're leaving out there, the top things on the list, and we're bringing in one of the 80-inch tethers that we usually would leave in order to tie it back up a little better. And we're also bringing the Essex and bayonet in to reconfigure the bayonet.
Correct. So we've got the 4 large big retractables and the 2 wrist tethers. And this last small I've got on the Hasselblad. Okay, I guess we're ready to come down.
Okay, Jeff, I'll start bringing you down.
Watch out for camera D here.
Okay, keep an eye on it for me, will you? Thanks.
We're clear. You got a foot and a half from it. You got 2 feet from it.
Jeff, look in here. Eyes are up.
Wait a minute. And I got my battery. going to hand me two things, Jeff?
I'm going to give you a super stringer and then the Hasselblad.
Okay. What's first?
The super stringer.
Okay.
Endeavour Houston, you are go for pivot and rotate.
Okay, we copy that. Great, we'll start on it.
Let me know when it's good, Jeff.
Okay, hold it there.
Stopping.
Okay, when you get it all clear here, Story, I'll untether. You ready?
Yes, I am.
I'm untethered.
There's something hanging up, okay.
I had it doubly tethered just in case. You're right. Sorry.
Yeah.
Okay, it's free now.
Endeavour Houston, stand by on the pivot, please.
I gotta put a hook on this thing here. Put a hook on it.
And where, sir?
Sorry, just put a hook on it here, sir.
Maybe I should try to put this camera on my mini workstation like I did when we came out. No, I won't. You got it.
Endeavour is currently approaching the equator on a southeasterly swing across the Atlantic Ocean on the 47th orbit of the mission. The crew members are wrapping up cleanup activities in the payload bay, and shortly Jeff Hoffman and Story Musgrave will be moving back into the airlock. In the meantime, the twin solar arrays on the telescope have been slewed back to the level position. During the EVA, they tended to move slightly, and they need to be in this position in preparation for the retraction procedures that are scheduled after the crew gets back inside.
Okay, I'm disconnecting from the yaw tether.
Copy. Hey, you're hooked up to Story tether now?
Not yet. That's just the yaw tether, Tom. I'm still on the waist tether. Excuse me, Tom. You're right. Get that right.
Endeavour Houston, you are now go for pivot and rotate.
Copy, Greg.
Space Telescope now being rotated in preparation for the retraction of the solar array.
That is from the end effector.
The solar arrays on the telescope.
And Kyle, we can see that Jeff has now left the end of the foot restraint at the end of the arm and is preparing to enter the airlock along with Story Musgrave. And I can probably say very safely that these two gentlemen are well satisfied after a long day and a hard day's work.
But you know what it's like.
Yeah, just thinking ahead.
I think it probably makes it a little easier once you know you've done been 100% successful on the task that you've been set out to do when you went out the hatch.
And even a little bit more than that, because they overcame the problem in good order and short order, and that made it a little bit sweeter for them and for everyone down here.
Well, they've just moved through 7 hours and 40 minutes since they started this spacewalk, and of course that included setting up the payload bay for the activities, changing out the rate sensor units, the electronic control units, 8 of the fuses on the telescope, as well as the additional work with preparing the solar array carrier and the forward portion of the payload bay for tomorrow's activities, and also getting a jump start on some of the other activities, including attaching one of the foot restraints to the telescope near one of the solar arrays, being a little bit ahead of schedule for that.
We're going to get stories tethered. Looks like my tether. Now I'm going to disconnect story front. Now I'm going to disconnect the yaw tether. Okay. I believe MFR is clear. Kathy, do you want to me to leave it straight up or tilted? Or
Doesn't matter. Just however's easiest to get on there. Straight away is usually the best.
that's the way I've left it.
Okay.
Okay, Fox, you can pull the arm away. I can get by.
Okay, Jeff, I'm going to take it up.
Great. And thanks, guys. Great driving. Yeah,
Sure, you got to put those too.
You want to come in feet first?
Yes.
And belly up, and then I'll...
Okay, stop the arm.
Stopping.
It's pulling on me.
Okay.
Let me...
Can move it out some. That looks like it might help.
Yeah.
What do you think?
Yeah, it's squeezing me against the bulkhead.
I got a nice clear area for you to come in.
A little further aft. Okay, I'm clear of it.
Okay.
Good. You'll be heading for that, your right side.
Okay, now I got to get the thermal cover.
Yeah.
Okay. Once you get inside, we'll get our water off and then the thermal cover, okay?
Okay. Okay, I guess I'm inside.
Okay, water off for both of you.
Water off.
That's your water story?
Go ahead, Endeavour.
I did.
Okay.
Greg, we pivoted down the HST on time, 3 minutes and 53 seconds. When we get the arm free, we'll go around and look at the protractor on the side.
We copy.
Okay, and then you get the thermal cover, Jeff.
See?
I'll put your legs up, Jim.
Just got to 4% power left. That was expected. Okay, I'm happy with that. Right?
Okay, you got the thermal cover, right, Jeff?
I do.
Okay, you can close and lock the outer hatch, and you might check those outer valves there. If you haven't bumped them on the floor, make sure they're still closed.
Okay. Check that out.
Endeavour Houston for KT. We think maybe camera Bravo might get you that pivot verification.
Be able to get...
It looks real good to us. It looks like it's about 15 degrees down. That's good enough for you, then we can start to rotate. Otherwise, we'll have to wait for the arm to go verify it.
You're a go to proceed.
Okay, we will rotate.
Yes, yeah. Yep. Where do you want me, Story?
Nowhere, Jeff. Anywhere you'd like to be.
Okay. I think we're in good shape. All right. Ready? I think Let it go. And let me check those, well, the covers are still on, so we never touched them. Okay, just a second. I got the STS. We're clear now. Okay.
Now push you up against her.
I'm holding. Feels like it's locked. Good. Locked. Okay, no, whatever locked. Good. Okay, well that's been locked.
Okay. Into the repress cue card.
Latch.
Outer hatch closed and locked. Double check.
Flashing it.
Double check water off.
Verified.
Remove DNC cover and Velcro it. Okay. Connect SCU and check lock.
Okay, I'll go get him, Jeff.
Okay.
Believe it or not, I have him tethered up nice here. Okay, here comes number one.
Okay. SU1 is on.
Okay, I'll go get two. Okay, two is on.
Okay, copy both on and check lock. Check the O2 valves are still open.
Astronauts Jeff Hoffman and Story Musgrave now back in the airlock, both on their service and cooling umbilicals in the airlock.
Okay.
As Kathy Thornton works through a procedure to pivot and rotate the telescope. The telescope's been pivoted forward slightly and now in a rotation procedure. This is designed to make sure that the solar rays are clear of the tail of the orbiter in preparation for a retraction of the solar rays, which will occur a little bit later this morning.
Okay, copy. You can check the meter on both. You can go to power to SCU. I'll record the MET.
Go to SCU.
Okay, understand you're both in SCU?
That's it. One is.
Jeff, you can check the airlock depress valve is still closed.
It is.
Okay.
Can I help, Story? Yeah. This one. Right? That's it, yeah. Okay. Okay, power restart. They're both in SCU.
Okay, copy that. Okay, take your O2 actuators to press.
One. Yes.
Okay, you got them both?
Yes, sir.
Okay, com mode to hardline.
Endeavour Houston, disregard the PDID com fail.
Houston Endeavour, we're starting the repress.
We copy, we're watching.
And Houston, if Houston, I'll make sure we want to go to the minus CSI attitude in the flight plan at 1 hour and 30 minutes after the appropriate time of rotation stop.
You are correct, Covey.
Okay.
Good, we're minus V2 forward now.
Copy, KT. Good work. Endeavour Houston for Covey. Just a reminder, we need an item 19 before going auto after your wait here post-rotation.
Roger, thank you. And Houston Endeavour airlock pressure integrity looks good. We're continuing the repress.
We copy that. Endeavour Houston for your info. We lost lock with the PDI data there for a little while and swapped to the aft low gain antenna. That's where we are now, and we have good data.
Thanks, sir.
The airlock aboard Endeavour is now back at that of the cabin pressure. This is Mission Control Houston. The Hubble Space Telescope has been pivoted forward slightly and rotated 90 degrees such that the solar arrays are clear of the tail of the orbiter in preparation for the retraction of the solar arrays. That will not begin until the next sunrise.
About a minute to LOS. We are not going to have Diego this pass. We will be back with you at 0226 on the west.
0226 on the west, Greg, we got it.
And as mentioned, we're about to lose the communications link with the orbiter and crew as the vehicle moves just to the southeast of Madagascar on orbit 47. The plans are being put into place as to the exact times as when the solar array retraction will take place, but the current plan is that it will occur in sunlight, and so we'll probably be waiting through the next night pass, waiting for sunrise, just as Endeavour approaches the Baja Peninsula on orbit 48. And in fact, Endeavour has moved out of range of our communications link. This loss of signal period will last for about 3 minutes. Our planned television event for our daily mission status briefing, today's briefing was scheduled for 6 o'clock. However, that time will change. The planned participants for that event, Milt Heflin, the lead flight director for this mission, Ken Ledbetter, the Hubble Space Telescope Program Manager, and Dr. David Lacrone, who is the HST Senior Scientist, are the planned participants right now for the briefing. The time will change based on the events that are going on in space right now, and for the lead flight director to take part in that. Milt Heflin's still on console here in Mission Control and will likely be here through the solar array retraction procedure upcoming on the next orbit. As soon as we get a firm time on that mission status briefing, we'll be passing that along.
Endeavour Houston with you on the west.
Okay, Houston, got you loud and clear.
Same here. affirmative, Covey. I do have 2 changes there in post EVA on flight supplement 9-3 when you're ready to copy.
Go ahead with the changes on 9-3, Houston.
Okay, 2 quickies, Covey. Step 41 can be deleted. And step 42 should be changed to perform supply water dump using FES. Step 1, that's a dump initiation, will dump about 3 hours.
Okay, understand. Step 41 deleted. Step 42 will be supply dump through the FES. Step 1, and it'll take about 3 hours for the dump that we're going to get.
It's a good readback. Endeavour Houston, Covey, I need to clarify step 41. The action to be deleted is the supply water crossover. All else remains the same.
Okay, we copy.
Endeavour Houston.
Go ahead, Houston.
Covey, a couple notes for you on the timeline. We're going to hold off on the latching slew until after sunset to avoid the jitter induced by the terminator crossing. The other thing is, and so we'll be giving you a call for free drift when that happens, so you can just relax for a few minutes there and expect that we will start the SDM retraction after sunrise, about 6 minutes after sunrise.
Okay, we copy. Latching slew will be after sunset, and we'll start the SDM retraction after sunrise, so we got a night pass here to kind of kick back.
Roger. Not much relief, but it's a little bit. Endeavour Houston, check camera over temp, please.
Yeah, we're going to take them all down for a while.
Endeavour Houston, go for free drift for the latching slew, please.
Roger, Houston, free drift.
Endeavour Houston.
Hello, Houston.
We're expecting the latching slew to be initiated at 0246. A reminder that we'd like somebody to have eyeballs out the window to watch the aft array in particular, so that if there is any kind of runaway condition, you can turn the SADI off. The latching slew is a very small tweak. You shouldn't see any movement. Should take about 20 minutes.
Okay, Houston, I'm looking out the window right now, and I can't even see the aft solar array in the dark. I'll put a mag line on it.
Okay, Covey, we now have the right answer for you, and that is that the ground has telemetry to watch this, so you can relax.
Okay, thanks.
This is Mission Control. Houston Endeavour has just crossed the equator to begin the 48th orbit of the mission. We're about 22 minutes away from the point at which Endeavour would pass from darkness into daylight. And the plan is to begin the solar array retraction at the point where Endeavour moves from darkness into daylight. As a result of the slip in the time to perform the solar array retraction based on the length of the spacewalk this morning, the mission status briefing will not occur any earlier than 8 o'clock this morning Central Time, and the participants will be based on who's available at the time that the briefing is set. Right now, again, we're not scheduling the mission status briefing until 8 o'clock or later, based on the progress of the mission, based on the solar array retraction, again, upcoming, beginning at the start of sunrise in space for the orbiter crew, and that's in about 20 minutes.
Endeavour, Houston.
Go ahead, Houston.
Covey, before we start doing the solar array retraction here, I wanted to pass along our compliments for an excellent job today. Just a superb effort all the way around by everybody on orbit. Also wanted to let you know that Story and Jeff are now the holders of the second longest EVA in the American space program.
Well, we had kind of figured that up here ourselves, that they were real close to that, and we're real pleased with the way things went today. It looks like like anytime you can declare victory on EVA day one, then you're doing pretty well. And I think we did that.
I agree. It was definitely a victory. We got 1 down and 4 to go.
And Greg, the old record holders of that second longest EVA are not upset at all.
Well, I'm not sure if I believe that. We'll take you at face value.
We're willing to hold third.
You'll have your chance.
Greg Harbaugh here in Mission Control, notifying the crew aboard Endeavour that Jeff Hoffman and Story Musgrave's spacewalk today became the second longest in the United States spacewalk history. The longest spacewalk occurred a year ago in May aboard the same vehicle, Space Shuttle Endeavour, on STS-61, and that was 8 hours and 29 minutes. Conducted by 3 spacewalking astronauts, Pierre Thuot, Rick Heeb, and Tom Akers, who is a mission specialist aboard this vehicle. Today's spacewalk bumped the 4th spacewalk on the STS-49 mission, which was performed by Tom Akers and Kathy Thornton, the 2 mission specialists aboard Endeavour for this mission. That was the second longest at 7 hours 45 minutes.
Go back to depth control.
Roger, going back to A-auto turns.
Roger.
Today's spacewalk officially 7 hours and 54 minutes.
Go ahead, Tom.
Yeah, just looking at the suit water recharge, it looks like we've stabilized at about 77% on tank Charlie. Looks like about 8% total the suits took, and kind of expected more than that. You guys happy with it?
We are happy, Tom.
Okay.
Apparently, those guys didn't work hard enough to use any more water than that.
Okay.
This is Mission Control Houston. We're about 10 minutes away from the point at which the one of the solar arrays would begin retraction. The retraction commands are sent from the Goddard Space Flight Center, the Space Telescope Operations Control Center. The plan is to retract the solar array, the good solar array, in this case the one that's closest to the shuttle crew compartment. And the rules call for the retraction to begin 6 minutes after the orbiter moves into sunrise. The sunrise on the orbiter is about 4 minutes from now, thus making the solar array retraction commands to start somewhere 6 minutes after that.
Endeavour Houston with one timeline note.
Go ahead, Greg.
I just wanted to make sure you were aware that we are carrying the next 2 daylight passes as options for SDM retraction activity. That pushes it right into your sleep just a little bit, but given that we want to wake up at the same time tomorrow as you did today, we believe that's going to shorten your sleep period about a half hour. We want you to think about that and give us any feedback on that.
Okay, Cubby will think about it. He'll get back to you in a little bit.
Okay, Si.
Endeavour is now approaching the terminator. That's the point on the Earth at which the orbiter begins to move from darkness into daylight. And as Greg Harbaugh just radioed up to the crew, we're trying to protect for the next 2 daylight passes around the Earth for the solar array secondary deploy mechanism retraction. The retraction of the first solar array is scheduled to occur in about 6 minutes or so once the orbiter's been in sunlight for about 6 minutes. Our daily mission status briefing currently is scheduled for no earlier than 8 o'clock this morning, and that's being dictated right now by this this last procedure for the day, and that is retraction of the solar arrays. The participants are still being discussed. However, the lead flight director for this flight, Milt Heflin, is a likely participant based on the conclusion of the activities before we put the crew to sleep.
Endeavour.
Go ahead, Endeavour.
Yeah, Greg, referencing your last call, we had anticipated that we would run a little bit later tonight when we saw that we were going to have to use the alternate daylight pass or potentially do that. And we feel that we can go to bed a little bit late and get up at the regular time tomorrow and go from there.
Okay, Covey, based on our pre-flight discussions, we thought that would be your opinion, but we wanted to double check. Thanks.
Yeah, and I just went down and re-verified that with Tom and KT, and they agreed that's the right thing to do.
Okay, thank you. Endeavour Houston, just want to verify you are set up for a video downlink for the STM retraction.
We're getting the video configured now.
Okay, thanks.
This is Mission Control Houston. We're standing by to reacquire a communications link in terms of TV so that we can get a view of the solar arrays for the upcoming retraction of the solar array secondary deploy mechanisms. The first to be retracted is the minus V2 wing, which is the solar array that is not damaged, and that will be the array closest to the orbiter crew compartment.
Endeavour Houston, we are standing by for your call for the bottom of 3-3 in payload ops.
Okay, Greg. You know, there is a slight twist to it, but it's about the way we've been seeing it all the time. It's as little twist as we ever see, and it's not going to get any better by waiting.
Jeff, we think 6 minutes is adequate.
Agreed.
Houston, do you want us to B auto burns?
Not required, Covey.
Okay.
Endeavour is still no downlink TV. And we've got good downlink.
Roger.
And we are go for free drift.
Roger, free drift.
This is a view of the solar array on the Hubble Space Telescope using the end effector camera. That's the camera mounted on the tip of the shuttle's robot arm for a close-up. And the commands are now in progress, being sent from the Space Telescope Operations Control Center located at the Goddard Space Flight Center in Greenbelt, Maryland.
Endeavour Houston, 30 seconds to motion.
Roger.
Endeavour Houston, we're looking at it. Say again, Jeff.
Houston, we have a flashing minus wing on the display. We still show deployed on the SDM, and we don't see anything visually.
Roger that, Jeff. We're looking at it down here.
This is Mission Control Houston. This is a view again from the end effector camera on the robot arm. The commands were sent to the secondary drive mechanism on this solar array, and while movement was seen, the solar array did not begin to retract.
Endeavour Houston, for your info, we're going to try to recommand using the alternate side of the DCE. And we'll give you a call.
We'll be watching.
We'll give you a call.
Okay.
The plan in place is to try an alternate path or a secondary path for the deployment control electronics, the DCE as it was referred to.
Endeavour Houston, DAP Auto, please. It's going to take us a few minutes to send this command.
DAP Auto.
Endeavour Houston, for our edification down here, would you give us your verbal description of what you saw, if you saw any indication of motion?
Well, we saw no indication of motion. The only thing that we saw was that the minus wings started to flash. Oh, that's on the display. Nothing at all on the telescope.
We copy.
While the new commands are being readied to be sent up to the telescope from the stock, the Space Telescope Operations Control Center, the crew was notified to put the orbiter back in digital autopilot, which is basically to keep the orbiter in the proper attitude. When the commands are ready to be sent, the crew is typically told to go free drift, which means that they disable all of the firing jets, the 44 thruster jets that are located on the nose and tail of the orbiter, to ensure that no thruster firings would impact the telescope or impart any movement to the solar arrays during the retraction procedure. This is a split screen view of two of the cameras aboard the orbiter. The one on the left is the end effector camera looking directly at the center of the solar array, the drive mechanism. The right-hand view is from one of the corner cameras on the payload bay. This camera looking toward the outermost portion of the wing solar array from the forward flight deck. telescope control center at the Goddard Space Flight Center, now turning on the secondary converter to the deployment electronic, or the deployment control electronics, or the DCE.
Endeavour Houston, free drift, please.
Roger.
Endeavour Houston, 30 seconds to motion.
Roger.
Endeavour Houston, this was another microswitch tripping. We're going to resend the command.
Roger.
Endeavour Houston, 30 seconds to motion.
Roger. We're seeing smooth, constant motion.
We copy, and we see it here.
Solar array secondary deploy mechanism retraction in work. Again, this is the good wing, or the wing that's not damaged, the solar array that's pointed or that's closest to the crew compartment. This retraction process takes about 5 minutes or so.
Motion stop. Houston.
We copy. Endeavour Houston, if you could give us some words on how you see the blanket rolling up. Is it rolling on there straight, uniformly?
Yes, Greg, it is. It looks very similar to what we saw at Bristol until it stopped.
Copy, thank you. Endeavour Houston, for your info, it looks like we've got a flaky micro switch that keeps shutting down the drive command, so we're going to reissue the command.
Okay.
That call indicating that the drive motor appears to be working fine. This very sensitive micro switch, when they call it a noisy micro switch, keeps tripping, and that stops the motor. So the plan is to keep sending the command. We did ask the crew if they were seeing the solar array roll up in an evenly fashion, and Story Musgrave was a crew member who radioed down that in fact he thought that it was looking straight as it rolled onto the secondary deploy mechanism in the center of the array.
Endeavour Houston, further clarification on this iteration. We lost the PDM stow indication, and that is what stopped the STM retraction. That implies a manual PDM stow tomorrow. So you might factor that into your thinking for tomorrow.
Okay, Greg.
Endeavour Houston, 30 seconds to motion.
Okay. And there it goes, Greg.
Roger, and we see it here. Houston, it's very smooth, just like Bristol. We copy, Story. Thank you.
The bias temps are all really straight now.
Roger.
Compensator bars look even.
Roger.
Solar array now well over halfway retracted. Again, this is the solar array facing the closest to the crew compartment. Endeavour is just moving across the southern tip of Africa on the 48th orbit of the mission.
We see it stowed here, Endeavour.
Look from here. Let me put the binoculars on. Looks good.
Payloads officer is reporting that they have gotten stowed indications on the ground.
Endeavour Houston, you're go to rotate.
Okay.
And Endeavour Houston, be advised we will be doing another latching slew during this night pass coming up. Endeavour Houston, we have a water dump request for you.
Roger, go ahead.
We'd like you to do a supply water dump using FES Step 1. That's 5-9 in the orbit ops.
Okay.
With the minus V2 wing completely retracted now, at least the secondary deploy mechanism part, the plan now is to rotate the telescope 180 degrees on the fixed service structure or the flight support system, and basically put the other wing in the same position for viewing, for camera viewing. And we plan to wait until the next sunrise to begin the retraction procedures for the second solar array, or the plus V2 solar array. That's the array that has the bent bistem on the outer portion of that wing. There was a conversation just a few minutes ago between Capcom Greg Harbaugh and the crew aboard Endeavour related to the primary deploy mechanism. The plan that's currently in place in the crew's flight plan is for these wings to stay in this position until tomorrow, until just before the second spacewalk begins, or which is in the timeline is scheduled for later tonight. However, the indications on the ground when the solar array was being rolled up a few minutes ago and it stopped the second time, the indications on the ground were that the primary deploy mechanism was slightly out of alignment, and if that remains the same, then the primary deployment mechanism is likely not to fold up against the telescope automatically, and that was the call that Greg Harbaugh gave the crew, that they may have to manually fold that array up against the telescope. That would be the only change to the flight plan in terms of the change out of the solar arrays at this point. This 180-degree rotation of the telescope will take about 12 minutes or so once the commands are sent.
Endeavour Houston, 2 minutes to handing down to Diego.
Roger, Greg.
And the telescope's now being rotated.
We see it.
Again, this will be a 180-degree rotation, basically putting the other solar array in the same position this one is in to allow for observations during the retraction process of the secondary deploy mechanism. Again, this rotation, this 180-degree rotation, takes about 12 minutes or so. Now, the plan now with this solar array rolled up, the plan is to wait until the next sunrise, which will be in about 45 minutes or so, before the opportunity to begin the retraction process once again for the other solar array. The same procedures would be in place to wait for sunrise plus 6 minutes, and then to have the crew place the orbiter in free drift, basically so that the 44 thruster jets that are located in the nose and tail do not fire during that process, so as not to impart any movement to the telescope or the solar array during the retraction process.
Endeavour Houston, we're going to take Diego off here in the control center. We'll be back with you on the west at 0410.